Hey everybody, Mr. Bowman here. This video is all for the Year 11 Elevate Maths exam that's coming up soon. Because you got a new layout, a new style, what we've done is we've created a practice exam for you to look at. And in this video here, I'm going to show you the exam, the practice one. I'm going to look you through it, and then we're going to go through all the answers together. So of note, there's the front cover, so it'll look exactly like that. And the first thing to note is you're not going to get an overall mark. You're going to get 4 sub-marks for each of the sections, and then finally, if you attempt the optional extension section, you might get an optional extension score as well. So the first thing you're going to see once you turn the pages, you're going to have this resource sheet. So this is the exact formula sheet you're going to get, and everything that is relevant, that's formula based, will come up in your thing. You can see you got the area of the triangle, you got some parabola formulas there handy, the straight line formula, expected number formula for probability, you got your gradient rise over run, interquartile range, and then finally you got how to find a probability. So all of those could be relevant in your exam. And then the next section of your exam is going to be resource 2, 3, 4. These are all the big stats graphs that you need for the stats section. So you've got a box and whisker graph with your confidence intervals, you've got a tarsog scatter graph with your line of best fit, and then finally you've got a time series graph with your seasonal effect. So all of those are going to be really useful, and you'll need to refer back to these pretty regularly during that stats section. So I suppose let's just get straight into Section A. Section A is going to be with 20% of your exam. Of note, you can see here instruction on timing for the section. You should aim to complete the section in 20 minutes. Each section, or most sections, will start off with some multi-choice questions and then some mathy or wordy questions after that. So let's get into question number 1 over here. So calculate the range of the graph below. And if you've forgotten what the range means, the range didn't come up in your formula. Remember, your range is your maximum minus your minimum. So I'm going to need to find both of those from my graphs. We can see the maximum over here. So go down there. That's your maximum of 34. You can see the minimum down here of 24. So you've got 34 minus 24 equals to 10. And luckily, that's one of my options. So the answer there would have been D. So we're now on to question number 2. Which of the following would best describe the given dot plot? So we're trying to describe this graph over here. And generally speaking, dot plots, there's a couple ways to describe it. You know, it could be symmetrical, it can be right skewed, or it can be left skewed. And you can see symmetrical, we don't have that here, right? Because we can't draw a line in the middle. This side does not match this side. So it's not symmetrical. This one here is looking pretty good. We can see a big lump on the left-hand side of the graph. You can see that there. And you can see the tail being stretched over there. So that looks pretty good. So that one's actually going to be right skewed because it's being pulled from the right tail. So that there is right skewed. And remember this one here, it's being pulled over to the left-hand side. So if you had that scenario, that there would have been left skewed. And in our case, we're going to have a right skewed data. So hopefully that's one of the options, and it is up there. Option B. So we're now on to question number 3. So the T in tarsog stands for trend, and the A stands for association. So we're dealing with the trend and the association. Which of the following would not describe a scatter plot's trend or association? So I suppose the way I'll probably start this is, so the trend can be one of two things, right? It can be a linear trend. So it can look like a straight line, or it can be a non-linear trend. So based on that, because it's a not question, we can eliminate those two answers there. We know it's not linear, we know it's not non-linear. And then finally, on the second part of it, that's also asked you to consider the association. And the association here can be positive or negative. So your graph is either going up or down. So that means it's not either of these two there. So that means the answer must be C, constant. And for your reference, C constant, that's actually an example from the scatter. And that makes sense. That reconciles with the question because it wasn't related to the trend or the association. So let's now get into question number 4. So which of the following does not describe the given graph? So if we draw a line of best fit, a line of best fit would probably look something like that, right? Not the best line, but you can see it's going upwards. So it's definitely going to be positive, right? So it's definitely going to be positive. So I can eliminate that one there. In terms of association, we can see that line of best fit's pretty good. So it's definitely going to be linear. So I can cross out my linear option. There was no outlier. And you can see here those purple dots are really close to that green trend line. So it's probably strong data. So that means weak So it is the correct answer. So it's strong data, which means it's not weak. So that weak description doesn't actually match the graph that we've got. So we're now into question 5. In what year was the birth rate equal to the death rate? So this is going to be a bit tricky. We're going to have to read the graph here. We can see the different shapes. I think your one will be black and white, but you can see the circles there. You've got the birth rate, which is the square, the death rate, which is the triangle. So we're trying to compare that one and this one here, and you can actually see those two lines don't intersect each other. So that means it's going to be this one here. It's going to be none of the above. So at no point they were equal to each other. And then finally, the last multi-choice question for the stats exam, we've got number 6. And if you were clever, this graph here actually would have helped you with the previous question or that. So if the data is left skewed, so that's going to be this data over here. That's different to the one we had before. Which of the following comments would be true? And just to note, this one here is an achieve mark instead of a developing mark. So the median will be equal to the mean. And we know that comment's wrong. So when you have a symmetrical data, that's when your mean and your median will be equal to each other. So those two are going to be equal to each other. So we know that comment's going to be wrong. And basically, when the data gets stretched in a certain direction, the mean moves with it, but the median is probably going to stay put. So that's when we see the mean and median going to be slightly different. So the question, or option B, the median will be less than the mean for left skewed data. So that's not going to be the case here because our graph is left skewed, which means we're getting pulled by the left tail, which means the mean should be dragged this way. That means the mean should end up being less than the median, I think. So I disagree with that because that's the wrong way around. The next question, or number C, the median will be more than the mean. I think that exactly matches what I'm talking about. So I kind of like this one, but let's read the next one. See, we'll need to see the data to determine which one's which. So we can actually cross that out because that's a bit of a false red herring answer. So the answer there is C. So that means the mean has been dragged down relative to the median. So that means the median will be more than the mean. Okay, so we're now into question number 7, and this question refers you back to the resources. So in particular, we're focusing on the box and whisker graph from resource 2. And it's told us about the population of the graph, so that's really cool as well. And we've been asked to compare the spread of the total length of male and female kiwi kingfish that are caught. Your answer should refer, or should include evidence from the graph. So I want to note, specifically read the question so you know what you're being asked to refer to, because you might want to use evidence from the context, you might want to use evidence from the graph, or something else. So make sure you're reading the one that you've been asked to do. So in this case here, the spread, hopefully you remember, the spread is asking you to compare the IQR, the interquartile range. So what I'm going to do here is I'm going to find the interquartile range for the female kingfish. I'm going to do the same for the male kingfish. And after that, I can make some comparative comments. So let's deal with the female data, which is the top. And remember the interquartile range. This was in our formula sheet. It was the upper quartile minus the lower quartile. And that's given to you in the red text. So we can see our upper quartile there, 131. So it'll be 131 minus the lower quartile. That's up there, which is 107. And if I do that subtraction, I get to 24. And now I repeat the same for the males. I've nearly circled the maximum, but I've got a upper quartile of 135. So it's going to be 135. And I've got a lower quartile of 105. So that's going to give me an interquartile range of 30. So what we can see there is we can see that the male data is more spread, more variable than the female data. So we now need to put that in a comment, and we need to put some evidence from the graph. So my evidence from the graph is basically the male here is going to be, its interquartile range is 6 higher than the female. So that's the evidence from the graph that I'm going to be looking to use here. So we've got, male kingfish, or spell that wrong. Male kingfish have a larger spread than female kingfish from our population. Oh, actually, we don't need to do that population stuff, do we? Because it's based on based on a sample. So from our sample. So I want to note first thing, for achieved, you need to have that comparative word. So that there would be your achieved comment. So the fact you told me it's larger and you've got males being larger than female, so you got in the right direction, is really important. So that's the woodlock you achieve. Your evidence from your graph now needs to back it up. So male kingfish have a larger spread than their female counterparts than their female counterparts because their interquartile range so their interquartile range, range is 6 larger than females. Okay, so that wraps up this question. So just to highlight it, we've had to do our calculations. The first sentence there, that's your comparative comment. And your second sentence, that's your evidence from your graph. And I just want to note this area down here, that's where my pause and play button is. So it's a bit awkwardly placed, so I can't really write in that area for the rest of the video. So we're now on to number 8. So we're carrying on with the kingfish graph. So that's why I've still got that over here. So from our sample, draw a conclusion about the total length of male and female kingfish from the population. Your answer should include a comment on the overlap and the conclusion drawn. Okay, so basically they've told us what they're looking for, right? They've told us we need probably a sentence on the overlap, and then we need a sentence drawing a conclusion overall about the comparison of the median weight of male and female kiwis. So the first thing to note, the overlap they're talking about are these blue confidence intervals. So if they overlap, then we can't be sure that one group will always be larger than the other group. If they don't overlap, it means you can be statistically confident that one group is larger than the other group. So in our case, we've got that overlap. So the first thing we want to talk about is that overlap. Forgive me as the text from the previous question is glitching a bit here. So let's start by writing down that. So the informal confidence interval forgive my messy handwriting, interval for the median weights of male and female kingfish they overlap, doesn't it? So that's the first thing. That's the really, really important part. So if they overlap, that then lets us make the overall conclusion, the decision, which needs to be my second paragraph. So let's talk about that. So this means we cannot conclude. So we can't conclude because of this overlap. So we cannot conclude that the median weight of male kingfish, I keep on saying kiwis because I always use kiwi data in my classes. I've written it there as well, now that I'm saying it, of male kingfish tends to be larger than the median, or the median weight of female kingfish. So the median weight of female kingfish. And I want to note, a lot of you are going to stop here, and remember that there is not enough to get you any marks, because we've forgotten about the really, really important, the population. So we're trying to make a decision about the wider population from the sample, and the population will always be bolded and distressed and exclaimed to you, so make sure you put that in. So that means we can not make the conclusion that males tend to be larger than female kingfish in our population. This is going to be really important. In our population, of, and then at this point here, I'm going to do a direct just copy and paste of the actual population. So I'm never ever going to reword it, because you can, if you reword it, it might lose its effect. But if you copy it exactly as it is, you'll never be wrong. So of all kingfish caught in NZ waters. So hopefully I've exclaimed and stressed that population part enough for you. So we're now into question number 9, and again this is a merit question here, and I just want to note the question simply says describe the trend. So this trend here, the answer is non-linear. I'll explain why soon. If you just write, it is non-linear, something like that, you're only going to get the developing mark, because you haven't linked it to context, you haven't attempted to link the keywords of the question to your answer. So if you're wanting to upgrade that to achieved, you've got to be linking the scenario, the graph, the variables to your comment. So let's start by doing that. So the relationship, and this is the word relationship here. It's not the relationship in terms of tarsog, it's the relationship in terms of the comparison between engine size and weight. So the relationship between a car's engine size and weight appears to be non-linear. Okay, and I want to break down why it's non-linear. So I think in this exam here, if you told me it was linear, I'd probably be wrong. So a lot of people are just going to look at this line and go, oh, that's right, it's linear. But remember, this discussion we're having is all about the data. It's all about the dots. It's not about the line that EasyGrapher just shoves on the graphs for us. And why it's non-linear, personally, I think if you look at this section here, that bit there kind of goes up fairly steeply. And then from then onwards, the line is flatter. It's more horizontal. And based on that, I think a curved response is the only really valid answer for this question here. So it's definitely a non-linear one. And as I said, the logic is from here to here, it's, that rate of change is quite steep. And then from here to here, that rate of change is quite shallow. It's kind of leveled off. So let's read the next part of the question. So your answer should include evidence from the graph. So again, it's not asking you for context, your contextual understanding here. It's just asking you for evidence from the graph. So I'm going to use this rate of change that I've mentioned here, that I've circled on the graph as part of my evidence. So it is linear. It is non-linear, rather, because the rate of change, oh gosh, it's terrible writing there, because the rate of change is not constant, And then I'm going to use some evidence. So from here, this sentence here, I haven't actually used any evidence from the graph. I've just stated words. So evidence from the graph means some actual numbers. And I'm going to use, kind of that point there, this 3 number here as part of my evidence. So anything before 3, going up pretty steep. Anything after 3, it's pretty level. So that's going to be the actual evidence I'm going to use. So the weight of cars between 1 and 3 litres, appears to be steeper than the rate of change for cars with an engine size of greater than 3 litres. With an engine size that is greater than 3 litres. Okay, we're now into question number 10, and question number 10 carries on from that CARS data, resource 3. So using the linear model, and just to note, the linear model is always this red thing from Grapher. So that's our linear model, our equation. Predict the weight of a car with an engine size of 3 liters. So 3 liters is what we're aiming to predict. As part of your answer, you should comment on your confidence in the prediction that you made. So first step, and this is actually the achieve part of the mark, is coming up with your prediction. So by writing this down, so let's kind of convert that into a sentence. So that basically is telling us you can calculate the weight of a car by doing 217.97 times by, I'll write E for engine size. And then once you've done that, if you add on 812.32. So if you take away the E, substitute and evaluate the whole expression, you'll have a prediction for our engine size. So in our case, we know that the engine size is 3 liters. So we're going to take away the E, put in 3. So that means we're going to have 217.97 times by 3 plus 812.32. And when I plugged that into my calculator, I got 1,466.23 kilograms. And I didn't need to round that, so that was an unrounded number. So there's your achieve mark. The next part of it is discussing your confidence in it. And the confidence we're going to have here depends on the point we got. So we can see the 3 liter up here. If we go up to the data, we can see that the data varies from up there at the top to all the way down there. Oh, I'm not sure where that circle came from. So that's where our data varies in that range there. And if you go across to the y-axis, you can kind of see, well, that's about 1350, and that there's about 1850. So our data at the 3 liter one doesn't really match the prediction that we've got. There's this huge variation. So that's the first thing I'm going to comment on. So our data at the 3 liter mark varies from, and I'm estimating these numbers, they might be slightly wrong, but 1,350 and 1,850 kilograms. Okay, this is a large variation. This is a large variation. Large variation for cars with an engine size of 3 liters. So that's the first thing to note. The other thing to note is you can see your line of best fit. So that green line there that I made before, that's the predicted value, or that's the actual data we're seeing. And we can see our red line. Our red line is the model itself. We can see our model is on the extreme lower end of those predictions. So that means our prediction is probably actually going to be a bit of an underestimate. You know, the middle of the 3 liter cars is probably going to be slightly higher, maybe in the 1600, 1700 range. So that's another reason that another thing that I want to mention. So I've talked about the data at that point. I'm now talking about how my model fits in that range. Our model predicted 1,466.23 kilos, which is at the lower end of the weight of cars with an engine of 3 liters. So based on those two facts, I'm not confident in our prediction, and in fact, I think our prediction is going to be an under prediction. So because of these reasons, I am not confident in my prediction. So I'll leave it there. And full stop. So we're now into question number 11, and this is kind of the first of the excellence questions, as you can see. So we're carrying on with our cars data, and the question is really nice and simple. It says, do you think the linear model is appropriate for predicting a car's weight? So when you're talking about if a model is good, what you're trying to do is you're trying to break the data into its smaller chunks. And I've already kind of done that here, and I'll talk to you shortly. And you want to check, does the model fit the data from the beginning of your axis all the way to your end of your axis? If the line is a good fit across that, or maybe there's only a few imperfections, then your model and any prediction from it is going to be a good one. If your model is trash in certain places, good in others, maybe that then means it's not appropriate at all. So let's show you how I got this kind of breakdown here. So looking at the graph, I can kind of see, I personally thought it was a nonlinear model. It looked a little bit like this. So when you have models like this, what it means is the first bit of your section, you can see our new graph is actually below the graph that we've got there. So you can see, so this section here, the line that we've got here, that red line, it's above most of the data. So that means if we were using this line to predict, our data or our prediction is going to be above what we actually should be having. So that's the first part there. So that's 0 to 2, less than 2 liters. That's where we got that from. The next prediction, I thought this 2 to 4.5 range, while it's not perfect, we can see there's probably a little bit more data above the line than below the line. It wasn't that terrible in that range. So it's particularly good here. It's maybe loses it a little bit there, loses it. But from there to there, that line cuts through that data really well. So I don't mind that chunk of the data. So between 2 and I called it about 4.5, 2 and 4.5, it was actually quite good. So then I need to talk about that. And then from 4.5 onwards, you can see these points here. So that line is actually going to carry on upwards here. We can see that line is well above our group of data here, which means our prediction is going to be over the cars that we're actually seeing. So our prediction again won't be good there. So based on that, we're going to discuss that in our 3 parts. It's going to be less than 2, it's going to be 2 to 4.5, and then it's going to be 4.5 to 5. We're going to discuss each 3 parts of those, and we're going to draw an overall conclusion on if we think the model is going to be good or not. So to help with this question here, I've got the mouse here, and I'm just going to type up my responses here because it's going to be a bit easier to do the fully worded ones typed up. So we're going to first start by talking about the less than 2 liter discussion. So for cars with an engine size of less than 2 liters, the line of best fit sits above most of the data we have. This means any prediction is likely to be an overestimate of weight, which I would not have confidence in. So any prediction we make there, we're probably going to be predicting over, noting the actual car weight is going to be less than that. So that's the first thing I want to discuss. So I've first done the first group. Let's now chat about the second group. So the second group, we didn't mind this one. The line of best fit largely cut through the middle of the values. Apart from this, there was some extremities in 3 that we talked about in the previous question, but ignoring that one point, the rest of the group looked okay. So let's talk about that there. And then similar idea, I'm going to use the same layout now. For cars with an engine size that is greater than 2 liters and less than 4.5 liters, the line of best fit roughly cuts through the middle of our data. This means our prediction might be reasonable. However, there is one issue in this range, that is the significant variation for cars with a 3-liter engine. So I just wanted to note that there, because that does cause doubt, because there were a lot of cars at that 3-liter number. So the next thing is 4 liters. We're going to repeat the same kind of structure, and we're just going to talk about how that there is going to be, the line of best fit is going to be well over those points. So 4 cars with an engine size that is greater than 4.5 liters, the line of best fit sits above all data points. This means any prediction using our model will be an overestimate. Okay, so I've talked about those 3 points. I can now wrap up and draw an overall conclusion. Overall, the model does not fit the data well. This means the model might not be appropriate to predict the weight of a car. So we're now into question number 12. See that up there, question number 12. And we're looking to chat about or fully describe the seasonality of the import. So this imports graph was resource 4 from the resource area that I showed you before, but I've got the graph over here. Your answer should include clear statistical comments. Your answer should also be justified with evidence from the graph and context. So this question here is a little bit different to our previous ones. We've got evidence from the graph is what the previous ones looked like, but it also said and context. So this means we've got to start thinking about beyond the data, the factual things that could have happened in the real world that might have impacted the graph that we're seeing. This is a big wordy question again, so I've navigated back to a text box here. So I guess the first thing to note is seasonality. There's 2 key things to seasonality that you need to be aware of in a given time interval. And in this case, it's years, because we can see we're breaking down the years into each specific month. So the first thing is we need to be able to discuss specifically all the peaks of the data. So at what time every year do we see this peak? And also we need to talk specifically about the troughs. So that's throughout the year at what point the graph is always at its minimum value. And that's what this little box on the right hand side does. So this January number 1st, we can see that's below the value there. So what this means is in January, they've added up every January number across that graph. They've averaged it out, and they've found out it's this much below the average line. And we can see the numbers are quite hard to read there, but we've got 3 zeros. So it looks like about 15 million, 10 million, 5 million. So those are our units there. So it's significantly below at times, and it's above at others. So let's start talking about the peaks, and we can see this is about the imports, but we can see that there's not a distinct peak. There's just a high period. So from, it looks like month 8 all the way to month 11, the sea imports, so that's the imports coming on boats through the ocean, it is at its highest, and that's about probably 2 million above that. So that's the first thing we need to talk about. So the way I always do is I always talk about what I can see. That's my statistical comment. So I see that the value of imports via New Zealand's seaports peaks between August and November each year. So that's my statistical comment. That's one of my achieve marks. So my second part, my merit stuff, I now need to back it up with evidence. So the evidence would be the 2 million that's above the trend line per time. So the value of imports peaks during this time period because imports between August and November are approximately 2 million above the long-term trend line. Okay, so I've now talked about my evidence from the graph, and that one there was quite easy compared to some other ones. Now the final thing we need to talk about is we need to talk about, why. What things, facts from the real world, would make the imports larger between August and November for whatever reason. And for me, I think the answer relates to the Christmas and the summer holiday period. So I think shops are busy importing all of their goods that they're going to be selling for the Christmas holidays, and maybe some summer gear as well. And I think that always comes in, probably starts trickling in August. I'm sure you might have been to Farmers. I went to Farmers recently and saw in September they were putting up their Christmas stock. So it kind of sinks in with that timing that I've seen out there. So the value of imports may peak between August and November because retail shops are busy importing inputting their Christmas and summer supplies. So we've now got the peaks one done, and I'm just going to expand this text box to give us more room for the troughs one. We'll get rid of all of that there. So we now need to start talking about the trough. So when is it at lowest point every year? And you can see the lowest point every year is in February. So we've got February, and we're going to follow the same process. We're going to start by having my statistical comment about the troughs. I then need to back up it with evidence from my graph, and it looks like it's about 2.5 million below the trend line in February. And then we need to back it up with reasons why. So let's do that. So I'm going to use my same sentence structure. So I see that the value of imports via New Zealand's sea ports has troughs every February. Every February. There we go. So that's my statistical comment. I now need to back it up. So again, similar thing, I could almost copy and paste the wording that I'm using previously. So the value of imports is at their lowest point every February because it appears to be approximately 2.5 million below the long-term trend line. So I've now backed it up with evidence, numbers from our graph. I can now link to context, and this bit's a bit tougher. I think the context of this is summer's ending, and if you think of the beginning of the year, once you hit February, you're past that peak summertime, there's no major significant events happening for a while. Like Christmas is still 10 months away. Maybe Easter's coming about, but apart from Easter eggs, what's the mass import of goods going to be at that particular time? So I think the time of the year relative to other major holidays which require imports is so distant that people just aren't importing at that particular time. The other thing that might be relevant is people's spending. People might have just spent a fortune during Christmas and summer, and most people's budgets are probably stretched that time of the year. So that means they're probably saving and not spending their money, and that'll probably apply the same for these retail shops too. So let's talk about both of those points. So the value of imports, okay, keep writing important. Imports may be at their lowest every February because there are no major holidays nearby, and consumers / retail shops may have spent significantly during the Christmas and summer period. So budgets and spending may be limited at this time of year. So that wraps up that question. So those contextual questions or comments at the end of it, they are tricky. You have to be very insightful. You've got to think about the real world and make connections with things you might see and do on a day-to-day basis to make sure you lock in those marks. But I think those first couple of sentences, I think anyone can do that. Anyone can write a statistical comment, and anyone can back it up with numbers on the graph. So you should at least be aiming for merit, a really strong merit mark for those types of questions. So that wraps up all of the questions from this Part A statistics section. Quite a long section, but I have been explaining and narrating what I'm doing. So hopefully you'll be able to smash through these in the allocated time. So just to note, just a reminder, you see all the letters in each of the question. This is DAME. So that means for this question, you could be awarded any of those marks depending on how you perform. And I'll just flick back to another one here. So this one here was DAM. So this is up to a merit, but you could get a developing or achieved depending on how well you do. AM means you can't get a developing mark for this, but you could get achieved and merit. And we can see the multi-choice ones. This one here is only achieved. This one here is only merit, also only developing. And same thing here. So if you are aiming to, for merits and excellences, you might want to consider not attempting the developing marks to maximize your opportunity to spend time on those harder questions. If you're not sure if you're going to pass or fail, if you're on the borderline, you probably want to do all the developing questions because they can contribute overall to an N2, which if you pass other sections, the difference between an N2 or an N1 might be really significant in terms of your overall achievement for this paper. Okay, so we're now into part B, section B. This is the probability one. It's worth 30%. So again, if it's worth 30%, you should spend 30 minutes on it. And the nice thing is if you fall a little bit behind on the stats section, probably park it at the 20-minute mark. But this section's quite quick, the probability section. So you might actually be able to save a bit of time here and maybe let back to stats at the end of that thing, or the end of that time, or this half an hour. So let's get into question number one. Question number one's first. What is the probability of a guaranteed event? A guaranteed event means it's certain it's going to happen 100% of the time it'll happen. So that means it's going to be option A. So 1 means it's guaranteed to happen. By chance, just so you know, an impossible event would have a probability of 0. A 50-50 event, one that may or may not happen, like a coin, that's going to be 50. And this last answer is nonsense. You can't have a negative probability, so it's definitely never going to be that one. So now on to question number 2. We've got Mr. Wood. He's asked his PE class if they want to do hockey or gymnastics. You can see that part of the Venn diagram there. The results of his class's responses are in the Venn diagram below. The question says, what fraction of the class wants to do gymnastics? So the first part of solving this question is we're trying to find a fraction. So we're going to be using our F over T approach, and that's in the formula sheet if you need it. The T stands for the total number of students surveyed, and that's going to be the addition of all of the numbers. So if we have 5 plus 6, that there's going to be 11, plus 3 is 14, plus 15 is 29. And that makes sense because 29 is a pretty typical class size. And specifically, he's asked us about gymnastics. So it's going to be those two there in that gymnastics circle. So it's going to be 6 plus 3, which is going to be 9. So the answer would be 9 out of 29. Hopefully that's one of the options, and I can see it is down there. Question C, or response C. So now on to D. What is the probability that the second bus was not late? So we can see the second bus section of the probability tree over here, and you can see the branches coming up here. So this section here is what's going to help us figure the answer out. So we're trying to find this not late number. So it's also going to be down on this branch here, but we can't really do much because we don't have that bit there. So not late, well, both branches have to add to 1, which means this here is going to be 1 minus 0.3. And when you do that maths, that's going to be 0.7, and that there is option A. So moving on to question number 4, we got that over there. So during a game, a coin and a dice are thrown. If you get a heads, your dice outcome is increased by 1, and that's what we can kind of see here. So if you got heads, we rolled a 1, so it's 1 more 2. We've rolled a 2 here, so we add 1 to get 3. Hopefully you can see that pattern happening throughout the graph. If you get a tails, it's doubled. You can see that 1 doubles to 2, that 2 doubles to 4, that 3 doubles to 6, and then so on. So we've got all that. What is the probability of scoring 7 or more? Now this one's going to be quite tricky. So again, it's going to be a similar F over T type question. And the T part's quite easy. So if you look at each of these blue numbers here, those are the unique possibilities that could have happened. And there's 12 of those in total, right? So we've got 2 times 6 to get that at 12. And now we've got to figure out, well, how many of them are 7 or more? So that's 7 or more, that's 7 or more, that's 7 or more, and that's 7 or more. So that's 4 different options. So we've got 4 over here. So that's 4 over 12. The issue is none of those are my answers here. So I do know, hopefully it could be a decimal, because you could convert that. So if you divide that by that, it's 0.333. And also if you times that by 100, that's the same as 33.33%. So it actually means any of those could be a probability, right? Because it could be a percentage, it could be a fraction, it could be a decimal. This time around, 0.33 is the magic one because I can see that there in my question. So we're now up to question number 5. Which of the following would correctly be the probability of a random boy liking rugby? So this is going to be difficult. This isn't a achieve question, just so you know. So we only care about boys in this group. And the boys relates to this column here. So the total here could be G, or I want to note, you could just add up the boys there. So it could have been A plus D as well. So it could be either of those. We don't actually know which one. And it said liking rugby, so it's going to be the A part of that. So we could find it out by doing A over G. That's not any of the options. I tried to trick you all here by doing G over A. That's not right. Or it could be this one here, which is actually option B, isn't it? So that one there I think was pretty tricky. I think a lot of people would have struggled with that one there. And then the last multi-choice question, question number 6. If a 3-sided dice is rolled, which would correctly calculate the number the number of possible unique outcomes. So when you're finding outcomes, kind of like this one here, we had 2 times 6, which gave us to 12. You just multiply the outcomes of each single outcome. So dice number 1 would have had 8 outcomes, dice number 2 would have had 8 outcomes, and dice number 3 also would have had 8 outcomes. So we're actually going to multiply all the 8s together to find the possibilities. So that's not going to be 24. We don't add them together here. This has got a random 3 here. That's wrong. And it makes sense because you've got 3 8s multiplying together. So that actually is the same as 8 cubed. So that means 8 cubed is going to be the answer to that one then. And again, that was with an achieved question. That's a nice one. Hopefully you're confident with those. Okay, so we're now on to question number 8. And you can see here there's a lot of easy achieved marks coming from this section. 3 achieved, 1 developing up there. So basically we've got a whole bunch of information here about the mid-year exams. They've done some information. They've done a survey on if people passed or didn't pass. They also asked each of those students if they did a comprehensive exam revision or if they didn't do a comprehensive exam revision. So we've got our table set up there. And the question here has asked us to complete the table. So in year 11, you're never really going to have the table partially populated or fully populated for you. You'll be expected to pull it all out from the sentences. And that's what we need to do here. So the first important bit is from the survey of 120 players. Assume that's meant to be students as well. So that's going to be 120 over there. We know that 45 students did not pass and did not undertake a comprehensive exam revision. So that's this one here. That's so did not pass, did not revise. So that's going to be a 45 over there. The next one, 67 students passed. So we can see the pass thing up here. So that means that's going to be 67. This number is really nice. It gives us a bit more information to calculate this missing number here. So 120 minus 67 has to be equal to this missing number here. And that there is 53. And this is actually really nice because it means we can go ahead and figure out this number here. That's going to be the 53 minus the 45, which is going to be 8. And then the final number, 57 people undertook a comprehensive exam revision. So that number's up there. So that there is going to be 57. And again, that means we can figure out this one here. That's 63. And because we've got no other numbers, it does mean we should just be able to figure these out normally. So again, same thing. So 57 minus 8, that's going to be 49. That's going to go up here. 49 plus 18 is going to get me to that 67. So that's 18 there. And double check the other way. 18 plus 45 is 63. So I know I haven't done any silly math errors on the way. So that there is an achieve mark. I think that's a pretty cruisy achieve mark to aim for. Question A, this is a developing one, but it won't take you long to do. How many students did not undertake a comprehensive exam revision? So not revision. So it's going to be those 63 there. So that's going to be 63 students. And I'm always going to write some words next to my numbers because it's important to tell the marker, what the context actually is. So 67 students. So we're now to question number 9. Calculate the probability that a randomly selected student took a or undertook exam revision or passed. So this is an or question. They're quite tricky. So if you focus on your central 4 numbers here, so it's these numbers that are going to be relevant. So because we're dealing with everybody, it's going to be out of 120. So we've got 120 people that we're investigating. And of those 120, of those numbers, 4 numbers in the middle, that square there, how many of them were exam, revision, or passed? So I guess we can start off with the exam revision people. So this group here and this group here, those people both did an exam revision. This group here, they didn't do an exam revision, but they did pass. So we're interested in those 3 circle ones. And this last one, this 45, we don't care about that number because it wasn't a pass and it wasn't an exam revision. So we're going to sum together those 3 numbers. That's going to be the top there. So that's going to be 49 plus 18 plus 8. When you add together that numerator at the top of that fraction, that's going to be 75 over 120. And you can leave that as a fraction, or if you want to, convert it to a fraction, which was 0.625. And because that's a probability, there's no context to add like that previous question. And that there would get you an achieve mark. Question number 10 is next. If the results were extended to the entire year 11 cohort, so remember this was only about 120, we're thinking the entire group now instead of just a survey, how many of them would you expect to have undertaken a comprehensive exam revision? So this here is something to do with expected number. So that word expect is always a giveaway in those questions. And the expected number is always going to be n times p. And again, that's on your formula sheet. So if you forget that, have that look. N always relates to the size of your bigger group. It's your sample size. And in this case, it's given to us above 575. So 575. And we're going to multiply that by p. That's the probability of the thing you're looking for expectation of. And in this case, we're looking for people who undertook exam revision. So we need to find the probability of the revision. So go back to my two-way table. You can see down the bottom there, 57 people undertook comprehensive exam revision. That was out of the 120. So that's actually going to be a probability of 57 over 120. And that there, you're going to plug that into your calculator, and you're going to get an answer. And I'm getting 273.125. And I want to note that's a bit weird because we've got a decimal number here, and we're not expecting a decimal number, right? Because we're dealing with a number of students. So that means we might have to think about rounding here. So 273 or 274 students are what we are expecting. So I'm going to write that down there. 273 or 274 students are expected to undertake comprehensive exam revision. Hopefully you're one of them. I suppose if you're watching this video, you're going the extra mile and looking through all of that. There we go. So we're now into question number 11, and this is one of the excellence questions. So you can get any of those marks on this one here. So we've got if 2 students are selected at random from the survey, what is the probability that exactly one of them passed and undertook comprehensive exam revision? So this question is going to be quite tricky. So the first thing we need to do is let's ignore this 2-student part of the question. Let's just focus on finding the probability of someone passing and undertaking a comprehensive exam revision. So that's the first part. So we're going to find the probability of passing and revision. And I'm going to go to my table to get those numbers there. So passing and revision, that's going to be those 49 there, right? So that's going to be 49 out of 120 people from the survey were going to be a pass and revision. So the issue is now this 2 thing comes into play. So that's the probability of one person doing it. So if I pick that person and a second person, put them together, what's the probability that only one of them had a pass and a revision? So not both, not neither, but just one of them. So one with, one without. And that's when the tree is going to come into play. So I'm going to call this pass and revision. I'm going to call this PR now. So we'll call that PR. So the first part of my tree is going to relate to the first person I pulled up from the survey. And they are either a person with pass and revision, or they are not pass and revision. And then we're going to write the probability. So the probability of this branch here was 49 out of 120. We now need to do the same for my next branch. That there is going to be the remaining people. So 49, so it's going to be the 120 minus the 49, the rest of the group basically. That's going to be 71. So that there's going to be 71 out of 120. Now I'm going to stretch the tree to be person number 2. So let's say the first person was PR, so passed and revised. The second person could have passed and revised, or they could have not passed and revised. And then we need to do the same for the second person. So if they didn't pass or revise, the second person could have been PR or could have been not PR. And the probabilities here are going to be different. So because it's from the survey, this probability can't just be moved here, and this probability can't just be moved here, because things have changed. There's now one less person in the group, because out of the 120, I've already got one aside, there's 119 left. So each of these probabilities here are going to be out of 119, so it'll be out of 119 for each of these possible things. And we now need to think about how the previous outcome is going to impact this. So if there were 49 people who passed and revised, and you've picked one of them, that means there's going to be 48 left. And that means the 71 down here, there's going to be all 71 of those people who did not do both of those. They are all still available in the leftover group to be picked. And the one down the bottom, it's now different. We're now on the other side of the coin. So person number 1 was not PR. That means all 49 people who were PR are still available to be picked. So that's going to go there. So we've got 49. And then finally, this 71, one of those persons were already picked. So that means there is 70 people to be picked. And this, if you double check your math, so 49 plus 70 is 119. And the same thing up here, 48 plus 71 is also 119. So I've now got that there. So I'm now trying to think of my outcomes. So I've got 4 outcomes, 4 branches of my probability tree. And I now need to consider which of them relate to the scenario I'm dealing with. And that is exactly one person being PR. So this top branch here, that's not exactly one because there's actually both people. So that there is a no, I don't care about that. This next branch here, we've got PR and not PR. That's exactly one. So I'm interested in this branch. Same thing here. We've got not PR and PR. So that's exactly one. So I like that branch. And then the bottom one here, this is not and not. So we don't care about that branch there. So my probability is going to be the sum or the addition of these 2 branches here. And those branches are going to be the multiple. So this first branch here will be those numbers multiplied together. And then the second branch would be those numbers multiplied together. So let's do the first one. So the top branch is going to be 49 out of 120 times by 71 over 119. So that's my first branch there. I'm now going to add on my second branch. That's 71 over 120 times by 49 over 119. So it's a bit messy, but we're going to add both of those fractions there. You're going to plug it straight into your calculator would be my advice. And when I did that, I got 0.4873, and that there had a 4dp rounding. So we're now on to question number 12, and we've got if a student did not pass, so that means we only care about the students who didn't pass now. So we've gone away from having 120 as our denominator because it's now a conditional question where we're going to disregard a group of our table. What is the probability they did not undertake comprehensive exam revision? So this is going to be an F over T type question again. And the first part of the question is figuring out the bottom, who do we actually care about from the table? And as I said before, we only care about the people who didn't pass. And the people who didn't pass was this 53 number here. So that's going to be the bottom of your fraction. And then the next part of the question is the probability that they did not undertake comprehensive exam revision. Of those 53, so that's this row here, who didn't do comprehensive revision? It's going to be those 45 there. So that means our probability will be 45 over 53, and you can leave that as a fraction, or I always like to convert these merit questions into decimals. That's 0.8491, and that there had a 4dp rounding. So that merit question there is a really, really good one. It's conditional probability. I think it's easy. A really good one to target regardless of your kind of the level and the goal that you're aiming for. So we're now on to question number 13, and the question asks us what conclusions can be drawn from your survey of sampled students. Your answer should include probabilities. Now, questions like this often back up and follow probability type questions. So this question here asked you to find out the probability that someone did comprehensive exam revision given they didn't pass. So it would make sense to make a comparison or draw some kind of conclusion. It would make sense to find, well, what's the passing equivalent? So this was the not pass group. What would that be if they passed? So I'll start by writing down my probability from the previous question. So probability of no revision given not passed. That was the answer to the previous question, which was 0.8491. So let's now figure out, well, what's the probability that someone had no revision given that they passed? So no revision given that they passed. So this question will be a little bit different. So we only care about the students passing, which is this top thing here out of 67. So that's going to be the bottom of my fraction out of 67. And of those 67, who did not do revision? That's 18 over there. And when I put that into my calculator, I got 0.2687, and that there had a 4dp rounding like my previous. So I can now actually make a conclusion. So from the two numbers, if you compare them, the people who did not do the revision were way more likely to be in the not pass group than the pass group. So let's put that in a bit of a sentence. So if you didn't pass, so the people who didn't revise made up a significant proportion of the group that did not pass. So that can be our first thing. So people who did not revise made up a significant portion of the group who did not pass. I think I'm going to run out of room here as well. So did not pass. Full stop. We'll carry on our discussion over here on this side here. And we can also talk about the opposite of that. People who did not revise were a small proportion of those who passed. People who did not revise made up a small proportion, spell that wrong, proportion of those who passed. Okay, so the overall conclusion from that is revising for your exam matters and it impacts the likelihood, or it'll help influence if you're going to pass or not. So this means that revising impacts if you are going to pass, and then I'll write in brackets, or not. Okay, so I just want to note that was one way of solving this question. There was another way to do it. You could have actually done, well, what's the probability of passing given you revised? And you also could have compared that with the probability of not passing if you didn't revise. And that there would have given you some similar outcomes. It would have been just the opposite. It means the passing proportion if you revised was really high, and the passing proportion if you didn't revise was really low. So you'd have a similar outcome if you took a similar approach. Okay, so we're now into question number 14 and question number 15, but this here involves all this context here regarding a big spinning wheel. So the context of this question is this here is a carnival game, and basically you spin the wheel and that decides the prize, and you can see, there's a major prize, no prize, we've got some lollies, another free spin, a major prize, a can of Coke, just some smaller prizes around it. But of note, if you're spinning this, you're probably going to win this major prize here. Mr. Turvey went to the carnival game. He tried 2 times and he didn't win the major prize, so he lost both of them. He has a suspicion that this here is rigged and it's not randomly generating outcomes. It's basically trying to avoid this major prize and give out these smaller minor prizes. So Mr. Turvey's stolen this spinning wheel, and he's now done a probability simulation to test if the spinning wheel is rigged or if it's a fair one, and maybe he just got unlucky. He's done this 1,000 times because 1,000 represents a good simulation, and these are his results over here. So question number 14, if the spinning wheel was fair, how many major prizes would Mr. Turvey expect? So this here is a theoretical question, so it's not actually going to be based on these experimental outcomes. It's going to be based on our expectation. So remember from our previous question, so your expected number is always equal to n times p. N in this case is going to be the 1,000 trials that Mr. Turvey's doing, and p relates to the probability of the event we're interested in, and in this case it's the major prize one. So that probability, you can see here, there are 9 different outcomes, right? So that means it's going to be 1 out of 9. So 1 out of 9, and if you do that multiplication in your calculator, it's going to become 111.11, and that number is actually recurring, but I'm going to round that to 2 decimal points. So in summary, you're really expecting about 111, 112 prizes somewhere in that area. So we're on to question number 15 now. Do you think the spinning wheel is rigged? Justify your answer by referencing theoretical and experimental outcomes. So I suppose the first thing to note is the theoretical outcome that we did earlier. That was from the previous question. Let's round that down to 111 now. So 111 major prizes. The experimental outcome, experimental refers to the simulation that Mr. Turvey's done. And we can see number 1, that relates to major prizes. There was only 52 of those when he actually spun it. So that there is going to be the experimental outcomes. So experimental outcomes, 52 major prizes. And by comparing these numbers here, we're going to get a rough idea of what's happening. So because we've done this 1,000 times, we're going to expect our experimental probability to tend towards the actual probability of the event or the item. So in this case here, this here is actually more 5%, isn't it? As opposed to the 1 out of 9 we mentioned here. So these experimental and theoretical outcomes, I think they're too far apart. So if we got, say, like maybe 105, 115, 109, something that's really close to this 111, that would probably be okay. That's a little bit of sampling variability from the experiment itself. But 52, that's way too off, and I think just impossible to happen if it's fair. So because of that, that probably gives us evidence it's rigged. So let's start talking about those ideas, and let's wrap up the conclusion that it's rigged. So our experimental probability, or our experimental outcomes for a simulation of 1,000 trials should tend, or whatever that was, misspelled there, so should tend towards the theoretical outcome with small differences for sampling variation. I wouldn't say, but with small differences. So small differences for sampling variation. So that was kind of what we're expecting. So we can now actually answer the question. So our difference here is not small, it's significant. So that tells us it's probably going to be rigged. So as our theoretical and experimental outcomes, I'm going to write really messy and small, outcomes have a difference of 59, so that's 111 minus 52, difference of 59. The gap is too large, suggesting it is rigged, and perfect amount of space. That was really lucky there. Okay, so hopefully you can see what we did there. We talked about what we were expecting theoretically and what our experiment showed us. We talked about the little bit of sampling variation we might see, and most importantly, we made a conclusion based on those two outcomes. So we're now into question number 16, and question number 16 was the second of the excellence questions. And this is a bit of a doozy, tough question to be honest. So basically we've got, carrying on with this simulation type scenario, we've got Mr. Turvey now wonders how the rigged spinner has changed the probability of winning at least one prize when you play the game twice. So that follows on with the context where he played the game twice and lost both times. He wanted to know, well, what was the probability that I should have won at least one of the prizes? So the question, I've even got the subparts for you. So part number 1 is calculate the theoretical probability of winning at least once when you play the game twice. So that's going to be a probability tree. It'll be a nice, fairly easy one though. The second part is asking you to do the same calculation, but with the experimental probability. So this here, remember, there was 1 out of 9 chance of winning the major prize, and here that probability changed to 52 out of 1,000 based on our simulation. And the final question is asking you to explain how the rigged spinner has impacted the probability of winning one of the prizes, or at least one of the prizes. So let's start off with question A. Let's do the probability tree for that. So this is the theoretical outcome, isn't it? So I'll write the theoretical up here just so I can highlight that a bit more for you all. So let's say you spin this. So this split here counts as the first spin. And the first spin, you can either win a prize or you cannot win a prize. And the outcomes there, so 1 out of 9 to win a prize. And then we've got 8 out of 9 to not win a prize. And then finally, we've got prize and not prize. And then finally, we've got prize and not prize. And again, that's the same there. That's going to be 1 out of 9, 8 out of 9, 1 out of 9, and then 8 out of 9. And this tree is a lot easier than the previous one we did because the probabilities aren't conditional. They're not changing from group to group. So thinking of my 4 outcomes down here, which of them relate to not winning a prize? Also to winning at least one prize. So here they won 2 prizes, so that's relevant for us. Here they won 1, and here they won 1. And this bottom one here we don't care about because that's 0 prizes, isn't it? So we don't care about that there. So this branch up the top here, that's going to be 1 out of 9 times 1 out of 9, which is 1 out of 81. We've then got 1 out of 9 times 8 out of 9, and that there is 8 out of 81. And then finally we've got 8 out of 9 times 1 out of 9, and that there again is 8 out of 81. When I add those all together, I get 17 over 81, which is equal to 0.2099, and that there was rounded to 4 dp. So that means roughly 1 out of 5 times, if Mr. Turvey did this 2 new games, 1 out of 5 times he should win one of the major prizes. So we're now going to move on to B, and as I said, that tree was actually quite quick. Didn't take us much time to do that. We've got experimental. We're now going to repeat the same thing, except we're now dealing with the 52 out of the 1,000 instead of the 1,000, instead of the 1 out of 9. So let's do that over here. So first one here, that's probability of winning the prize, not winning the prize. So as I said, that's going to be 52 out of 1,000, and that means the remaining 948 out of 1,000 will be the probability of not winning a prize. We then split this up again. Let's do a little less of a split to have more room for the working later on. So prize, not prize again for both layers. So same thing, that there could be 52 out of 1,000, and that there is 948 out of 1,000. And repeating that, that's 52 out of 1,000, and then that there is 948 out of 1,000. So now that I've got that, I know from the previous question, I don't care about the bottom branch because that was not winning any prize. So I only care about these prizes here. So that's going to be 52 over 1,000 times by 52 over 1,000. And then the next layer, that's going to be 52 over 1,000 times by 948 over 1,000. And then the next last column, 948 over 1,000 times by 52 over 1,000. And I haven't calculated each of the probabilities separately just because I ran out of room. But if you plus all of these three together on your calculator, when I did that before, I had a probability of 0.1013. And again, that was rounded to 4 decimal points. Again, because the rounding, you might take a different approach. Your rounding might be slightly different to mine. That's all good as long as you're close to my answer. So I've answered A, I've answered B. Now the last question has asked me to explain how the rigged spinner has impacted the probability. And we can see here, it's gone from 0.2099 and it's fallen to 0.1013. So this rigged spinner has roughly halved the probability of winning one of these major prizes. And that's the thing that we're going to talk about here for our last mark. Explain it's halved the probability. So the rigged spinner has roughly halved the probability of winning one prize, or at least one prize, right? I should be more specific. With winning at least one major prize if Mr. Turvey spun the wheel twice. So we're now into section C, which is part 1. That's the 30% algebra section. I call this the linear algebra section because none of the quadratics are in their section. So this section is going to be really important. If you're putting a case to get into 12 stats or 12 math, you need to have basic algebra in terms of your linear algebra skills, and that's all going to sit in this section. Just a reminder, all of the double brackets, all of the quadratics, all of the parabolas, none of those are in this section. Those are all section 1. Also, it's the section D, which is Algebra 2. So let's get straight into question number 1. And the question is, and this is a goodie, I always like putting these questions in exams, which of the given expressions is not equivalent to the others? So the way I approach these questions is I will try to simplify each of the expressions, And basically one of them is going to be the odd one out. So let's do A. So we've got 10y minus 5y plus 1y. That's going to get me to 6y. B, that's going to be 12y divided by 2y. That's also 6y. So again, they match. So the answer is going to be one of the bottom two. We've got 4y plus 2y. That's y, or 6y. Reminder, a lot of people do the wrong error. They do y plus y to get y squared. Remember, that's wrong. And then the last one, we've got 2 times 3, that's 6. Y times y, y squared. So this is the odd one out here. So D is going to be the answer because that created a power through that multiplication. Now on to question number 2. What is the coordinate of the y-intercept? So here you just really need to figure out, which one's the y-axis and where does the parabola hit that. So we can see this point up here and here, those aren't the y-intercepts. Those are your two x-intercepts because they're intercepting the x-axis. This point down here, I'll give that a cross. That's the midpoint of your parabola. That's the vertex is what we call that. So it's not that. And we can see this last point, up and down there, that's your y-axis, which means that point there is your y-intercept. So that's going to be C for that question. And then question number 3, what is the gradient of the given graph? So before we look at the options, remember the gradient comes from rise over run, and that's something given to you in your formula sheet. So to do rise over run, I try to make a bit of a triangle. So I'm going to go from this orange point to this orange point, create a triangle there. So if I go down and then across, I can make a bit of a right angle triangle, and that's my rise over run. So I've gone down 3, so that's going to be -3, and I've gone across 1, that's 1. So my rise over run, I would have a rise of -3 because it's going down, a run of 1, and that there simplified gets me to -3, which is option B. So it's not going to be any of the other ones. So we're now into question number 4. The question is, form an expression in terms of n for the following. So an unknown number is increased by 5 and then quadrupled. So there's a few things I want to circle. So I suppose increased by 5 is one part. Then is actually a really important word here, and then quadrupled is that part there. So to break down the question, so the word then means it is quadrupled after it's increased by 5. So that means we've got to increase it by 5. Oh, we're writing an x, but we need an n. So it's going to be n plus 5. And then because of bed mass, we've got to say, I'm going to put some brackets in here because I want that done first. And then we multiply it by 4, which means we put that 4 out front. And then that there would be the answer B. On to number 5 now. So we've got our expression -2b over a, and we know that a is -3 and b is -6. So let's just jot that down over here. So we've got -2b over a. So -2b, so b is -6, so it's going to be -2 times -6, and a is -3. So let's do the top of the fraction first. Negative times negative is positive, so that's going to be 12 over -3, which is equal to -4. And that there is going to be option A. And then finally, for achieved, a nice achieve mark in this multi-choice section, what type of pattern is it? So we've got our list of patterns. So to classify the type of pattern, you've got to start exploring the first and second differences. So let's see. So how do I go from 64 to 16? Well, that's going to be -48. So we've got -48. And then from there to there, that's going to be -12. There to there is -3. And there to there is -0.75. So none of the first differences are the same. That means we know it's not linear. I suppose we could rule out cubic here because we didn't actually learn about cubics. So that's a bit of a trick question. And then the next question, to figure out which one of these it is, it's the second differences. If your second difference is the same, it's a quadratic. If your second difference is different, it's exponential. So to go from here to here, that's 36. Here to here, that's 9. There to there, 2.25. So we've got different second differences. So that means it's not a quadratic because they had to be the same. So that means it must be an exponential function. So we're now on to the next section. So we're moving away from the multi-choice question. So in the exam, there'll be a few questions where you've got to form some expressions from context. That's what these ones are. So question number 7, form an expression for the area. Be careful with these ones. A lot of people do perimeter when it says area, area when it says perimeter. Read the question thoroughly for the given trapezium. So I suppose we can start by writing down the area of a trapezium, which is given to you in the formula sheet. So a plus b over 2 times height. Remember, the top of your trapezium is A, the bottom of your trapezium is B, and obviously the height over there is going to be h. So let's sub that all in. So I'm taking away the a, so that's going to become 2x. So it's going to become 2x plus b, which is 4x, over 2 times by 3x. Now I've got my BIDMAS to do because I've been asked to fully simplify this. So remember, BIDMAS is really important, but we've got those invisible brackets there. So we do those first. So that's going to become 6x over 2 times 3x. That there is going to be 3x times by 3x. And when I do that, 3 times 3 is 9. X times x is x squared. So 9x squared would be my answer to that one there. So we're now on to question number 8. These ones are a bit unusual, but they're pretty typical algebra type questions. So form an expression for the sum. So sum, that tells us there's going to be a lot of addition happening in this question for 3 consecutive even numbers. So to highlight how to do this, I'm just going to write down 3 consecutive numbers. So 4, 6, 8. They would be 3 consecutive even numbers in a row. So to go from here to here, I've got to go plus 2. And then to go from here to here, I have to do plus 4. So by subbing out 4, so instead of pretending it's 4, let's pretend it's n, because we've been told n is the first of these numbers. That means the second number would have had to be n plus 2, and the third number had to be n plus 4. If we simplify that, we've got 3 n's, so 3n, and then the constants up there adds to 6. Okay, so we're now on to question number 9, and that revolves around this thing here. So Mr. Bowman is considering an online Pokemon card shop, just related to something I'm into, to investigate how Pokemon packs, how to price them. So he's trying to figure out, how should he charge his customers. He is looking at 2 competitors. So he's going to investigate how Business A deals with it, and then how Business B deals with it. The pricing model for Business A is shown below. So this here is how Business A does their selling of Pokemon packs. And then the actual question itself, by considering the gradient and the y-intercept of the graph. So you can see the y-intercept over here, and don't forget it's rise over run to find the gradient. Explain how Business A's pricing models works. So the easiest thing to start off with is the y-intercept, right? Because we can just look at the graph to see that. So the y-intercept, that starts over here. So it's a bit annoying to figure that out, but we can see this 25 is chopped up into fifths. So that means each box must be 5. And we can see the y-intercept happens after 2 boxes. So that means the y-intercept is happening at 10. So our y-intercept is 0, 10. So that means there's a fixed fee of $10. And that occurs regardless of how many packs you order. And if you think of the context of the question, that's probably going to be your delivery fee. So this would be a $10 fixed fee, such as a delivery charge. Okay, so we've considered the y-intercept part. We can now do the gradient part. This one's a bit more annoying to deal with, but let's get into it. So remember to find the gradient. It's always rise over run. So what I'm going to do is I'm going to scan along my graph until I can see another point that's really clear. So you can look here. That's pretty clear, but I'm not quite sure what's happening. But I really like this point up here. So if I go across here, so that's going across 2 and up there. So that's going up by 1, 2, 3, 4 boxes. So that means it's going to be up by 20. I can find the gradient. So the gradient here is going to be, remember, rise over run. Again, on your formula sheet. So that's going to be 20 over 2, which is 10. So basically what that means is as we go across 1, it goes up 10. So what that probably means is there's going to be a $10 charge per pack. So each pack is going to cost $10. Each pack is going to cost $10. Okay, so we've done that question there. We're now on to question number 10. Business B's pricing model is different. It has a membership fee of $25. This includes free delivery and access to $8 pack deals. So $8 packs is pretty cheap at the moment, probably too cheap to make any money off it. So form an equation for Business B in terms of X and Y, and then after that we've got to draw it on our graph. Okay, so in terms of Y and X, so our equation is going to be Y equals mx plus c. M is going to be the gradient. that's the charge per pack like we had in the previous one. So we know that's going to be $8 in this particular deal. And C is the constant. That's like the fixed charge that you get charged regardless of how much you purchase. In that case, that's going to be the $25 membership, right? Because you can order 25 packs, 0 packs, whatever it might be. So that means our equation, our model, is going to be y is equal to 8x plus 25. Okay, so now what I'm going to do is I'm going to draw this on my graph. The way I would probably be doing this is I'll probably just pick a couple points. So if x is, if x is 0, 5, and 10, how much would that cost? And then that'll give us a few coordinates to put in. So if x is 0, that's going to be $25. If x is 0, it's going to be 8 times 5 is 40 plus 25. That's going to be $65. And then the next one will be 80 plus 25. That's $105. So let's plot those points. So 0, 25 is going to be right up there. We've then got 5, 65. So we're going to go to 5 and then up to 65. 5, 65. That's going to be over there. Hopefully you can see the dots pretty clearly. And then finally we got 10, 105. 10, 105 is going to be that point there. Okay, so I've connected those dots with just one of the clip out lines, but hopefully in the exam you'll be drawing a nice straight line with, the side of your ID, a ruler, just connecting those points perfectly, which will be really good. Okay, so we're now on to question number 11, and for this question here we've been asked to calculate the point of intersection for business A and business B's pricing model, and then it says to use your answer to explain when a purchase from business A and business B will cost the same amount. So this question, bit of a trick to it, but hopefully you'll be able to pick it up as I do it. So the first thing is we need to form an equation. So remember that bottom red graph, that there was business A, and the top green graph, that there was business B. And what the question's trying to find us is, can you see here how the red graph is cheaper initially, and then eventually it becomes more expensive? So we're trying to figure out, well, somewhere in this area here, it turns over. So basically business A becomes more expensive. We've got to figure out that point. And then we've got to talk about when they're going to cost the same amount. So let's start by doing that. So the business A model, we didn't actually calculate the model from the previous question. We left it as a y-intercept at 10 and a gradient at 10. So that means the business A or business A's model was actually going to be y equals to 10x, because that's the gradient, plus 10, because that's the y-intercept. Business B, we did form the equation for that, and then just copying that from the previous question, that was y equals 8x plus 25. So I've now got that question here. So now I'm going to use my simultaneous equation skills to solve it. And the giveaway of this is, see, I got x and y. We don't know either of those. So two variables means you need two equations to solve them through simultaneous equations. So the way I'm going to do it is, they're really nicely ordered. If I do y minus y, that'll eliminate the y's, right? So we're going to do pricing model A minus pricing model B to do that. So as I said, y minus y is 0. So that's going to be equal to 10 minus 8x is going to become 2x. And this one's going to be a bit tricky, but might be a math error here. So it's going to be 10 minus the 25, which gets me to negative 15. I can now solve this. I've eliminated the y's. There's only an x. I can solve for x. So I do that by going plus 15 to both sides. So we've got 15 equals to 2x. And then we've got divide by 2, divide by 2. X is equal to 7.5. Now this here is interesting because we now have to use it to explain when purchases from business A and business B will cost the same amount. And in this case here, it's a bit of a trick. You can't buy part of a Pokemon pack. So this answer here tells us if we bought 7.5 packs, it would be the same cost, but we can't actually do that. So let's talk about that. So our solution of x equals to 7.5 tells us if you buy 7.5 packs, the prices will be the same. So that's the first part of the answer. So if you did that, you'd probably get achieved, but we now need to critique that. You can't buy half a pack. So that means there's no combination of packs that will actually have the same price for these people. If you bought 7, business A would actually be cheaper. And if you bought 8, that's when it flips over to business B being cheaper. So I'll write, as you can't buy half a Pokemon pack, forgive the messy handwriting there, there are no combinations that will have the same price, have the same price from either business. Okay, so we're down to question 12, and that's going to be one of the excellence questions for this Algebra 1 section. There's a second one coming up soon. But Mr. Bowman wants to create an online shop to be the cheapest for his customers. And your question is, develop a pricing model that will always be more competitive, which means more cheaper than both of the business models from A and B. And we've got a whole bunch of things we need to do specifically. We need to include the equation of the pricing model that's going to be cheaper. You should explain what the pricing model means in context, and you need to justify why your pricing model will always be cheaper than the other pricing models. So let's start off with that first bullet point. So let's kind of construct our pricing model, and this is going to be most of the work here, most of the thinking, because the rest is us just kind of justifying what we're doing. So I think there's a few nice tricks to do. So firstly, to be the cheapest down here, it has to start at 8 and kind of be shallower and pop underneath that red graph, or it has to start lower and kind of go up in line with the red graph. Obviously, we don't just want to kind of shove it down here because you're going to lose money in the long run, so that's not a good pricing model. So what I'm going to do is I'm going to think, well, let's do my y-intercept at the same point. Let's do a y-intercept of 10 as well. So that means I'm going to start there, and I'm going to aim to kind of scoot it on underneath there. So the other issue we've got in the long run is we need to find the gradient as well, I should note. So we've got to find the gradient. And the other issue we have in the long run is when this green graph goes up and up and up in this direction here, it's actually going to become less cheaper. So the gradient of the green graph is actually more favorable, right? So that the cheapest bit here is the y-intercept, but in the long run, the gradient of the green one is cheaper. So we're going to need the same gradient as the green graph or business B. So if we do have that, what we could do is we could just run the graph, parallel, but underneath the green one. So that means we'll never catch up and overlap the green one there. So we'll always be better than the green one. And we're avoiding this kind of red stuff in the middle where the red group is initially cheaper than the green one. So that means we're going to need a parallel line to business B. So that parallel line would have the same gradient, which means we're going to have a gradient of 8x. So that means our business model, not 8x, just 8. So that means our business model is going to be y is equal to 8x plus 10. So we've done the first pricing model. So that one's always going to be cheaper. It's just a parallel line that starts at the start point where business A is. So it's always going to be underneath. And then just a note, so technically down here at the 0 mark, it's actually the same as business A. But that's when you're buying 0 packs. So that doesn't really matter. It doesn't really affect Mr. Bowman's business that he's trying to set up. Okay, so we've done A. The next part is explain what the pricing model is in context. So this one here is probably going to be, so your $8 is your cost per pack, and your $10 is your fixed charge. And I think just because I do a lot of postage for Pokemon stuff, a little parcel normally costs $6 to $8. So that's probably a nice thing. I could, buy some Lush bubble wrap and some fancy boxes, and that can be the delivery charge, including the postage and the extra stuff that I need to do. So let's explain that. So Mr. Bowman's pricing model includes a price of $8 per pack and a $10 delivery fee. Okay, so I've now done that second bullet point. I've explained what it means in context. And the hard part, I now need to start justifying it. And remember, the justification that we talked about had two facets. It had the first one starting at the at business B's kind of start price. So that means it's cheaper initially. And then obviously running it parallel to that business B pricing model to make sure that business B doesn't overtake us like it did here. Okay, so I'm going to do my answer kind of on this side here. So this pricing model will always be cheaper than both business A and business B. Business A and B. It will be cheaper. This is where the justification will become. So it will be cheaper because it will start at the lower y-intercept for business B, or business A, sorry, for business A, and it has the smallest gradient from business B, which means we will undercut business A's 1 to 7 pack price. I'm going to run out of room here, so I'll talk to the rest. And this is when we talk about, it being parallel to business B, and therefore always cheaper than business B. And that's what you would have needed to do to talk about in that last step before I ran out of room. So just noting for this one here, if you kind of got a relevant pricing model, you probably got achieved. Just to note, even though it didn't specifically say what the pricing model was, if you put in a line just kind of there, you're not going to get your full marks for that because that's a bad pricing model. If you're thinking of the context, Mr. Bowman's business is going to be run into the ground and never make money. So that you wouldn't have got full marks for that. So you might have got like an achieved, maybe a merit if you really sold it, but you wouldn't be able to get full marks. So achieved was probably going to be the model itself, good or bad. Merit probably would have been a discussion of the model, again, good or bad. And excellence, you'd really only be able to get excellence is if you had a good pricing model that was close and competitive to the other two businesses. Okay, now on to question 13. So we're moving on to like the solving type questions. And first thing to note, this one here is a tricky. Do you see how there's no number in front of the bracket there? That's a big high risk of a math error, so be careful with these questions. So let's start by expanding that. So we're going to go this times this. So we'll do an equal sign there. So that's going to become negative 10a. We then repeat by doing this times this. That's going to be negative 5b. And then this is where we repeat. Imagine if that was a minus 1 there. Minus 1 times 3 is minus 3a. And this is where the math error is going to creep in. A lot of you are just going to write minus 2b there because you got minus 2b there. But that's wrong. Remember, it's negative 1 times negative 2b. That's going to be positive 2b. I can now simplify simplify all of these. Let's do the a's. Negative 10 minus 3 is going to be negative 13a. So we've got negative 13a. And then we've got negative 5 plus 2. That's in relation to the b's. That's just going to be negative 3b. So we've got that one there. Question 14 is up next. Fully factorize this. This is a bit of a doozy. It's only a single bracket one. So it's on the easier side of the curriculum. But there's a lot going on here, so let's do that. So the first thing to look is, what does each part have in common? So I know for sure everything can be divided by 5, right? All of these are part of the 5 times tables. So we're going to have a 5 in common. So let's write that 5 down first. We're now going to look at the a's. So we've got a squared, a4, a3. So the smallest amount of a's is the a squared. So it means I can factorize out and take the a squared out. And then we look at the b's. What's the lowest amount of b's that they have in common? It's going to be that single b down the end there. So we can take that b out. So we're going to go b. So we now figure out our open bracket. Remember, each of these, we're going to go divide by 5a squared b, because we've just taken out that 5a squared b. So we can do that. So 15 divided by 5 is 3. A squared divided by a squared, a's cancel out. And then we've got b cubed divided by b becomes b squared. We then go minus. Same thing here. We're going to go divide by 5a squared b. 25 divided by 5 is 5. A4 divided by a squared is a squared. B squared divided by b is b. And then finally, the last one there, saying the same process, divide by 5a squared b. So we've got 20 divided by 5 is 4. A cubed divided by a squared is just a single a. And then b divided by b, they cancel out. And we do a close bracket. And then we've got that there. So we're now into question number 15. Fully simplify this. And this one's quite nice. What we're going to do is we're just going to factorize that top there. So that top, they've got a 2a in common. So it's going to be 2a bracket a minus 4. And then all of that there is going to be over 4a. And then now that I've got that, I can cancel out the a's on the top and bottom. We've got 4 over 2. That just simplifies to a half, isn't it? So that's going to become a minus 4 over 2. And there kind of is an invisible 1 up the top to represent the half, but we ignore those invisible ones. And then we're now dealing with some power rules. Question number 16. These ones are quite nice if you know what you're doing. So hopefully it's something you'll take away and take with you in the exam. So this squared is on the outside of the bracket. The trick with this question is it doesn't just hit the letters, or the x there because it's next to it. It hits everything. So it's going to become 4 squared, which is 16. And then x squared. And then 5 squared, so that's going to stay on the bottom. And then also y squared. So every part of that, the 4, the x, the 5, and the y, everything got squared. And that there is our answer. Because it's a fraction, you just got to check if there's any common factors on the top and bottom, but we don't have any here. So we're now up to the solving section. And remember, to be awarded full marks, you must include your working and algebraic thinking. And another way of saying that, that's just your opposites. So let's do that. So we've got letters on both sides. So that's why it's kind of just a year 10 skill, because there's no real fractions involved. Fractions make it year 11. So let's recap this one here. So we're going to take away the smallest amount of the letters. And basically that cancels that out. So that's going to give us 6y minus 20 equals to negative 2. Now that I've got that, I can look to simplify, or to solve rather. So I'm going to go plus 20 to cancel out that. So 6y equals to 18. And then I'm going to go divide by 6, y is equal to 3. And just to note, even though this is a developing question, if you're not sure if you're on the borderline of passing, like do attempt the developing marks, because there's a big difference between an N1 and an N2 in terms of how we look at it. So make sure you're getting the N2s, not just kind of passing on them and getting N1s. Okay, so we're now on to question number 18 now. So another solving question, and we can see the fraction part of that. There's a fraction there that's going to make it a year 11 question, hence why it kind of creeps up into the achieve part of the curriculum. So the way I do this one here is that x up the top there is locked away in the brackets. So I can't do anything with the x or the 6 or the 9. So I've got to move this 4 to the other side, and it's currently a divide by 4. The opposite of a divide by 4 is a times 4. So we're going to times 4 to both sides. So that would cancel out. So that's going to be 6x minus 9 is going to be equal to 12x. So similar to the last question, I've now got x's on both sides. So I'm targeting the smallest of the x's, which is that positive 6x there. So to get rid of positive 6x, I need to go minus 6x. So minus 6x to both sides. So we've got negative 9 equals to 6x. I now need to do the opposite of this 6, and because it's a times 6, the opposite is going to be divide by 6. So divide by 6. So that there is going to be negative 1.5 equals to x. Just noting, I've got that in the decimal form. You might have done like negative 9 over 6 and then simplify that to negative 3 over 2. That's 100% okay, and you'll still be getting full marks for that as well. So now into question number 19. We've up into the merit stuff, because we can see kind of like a double fraction here. So that obviously makes it a bit more complicated. But the double fractions are ones that I don't think you should be stressed about. We do a cross-multiplying approach. So that numerator is going to be times by 5. That denominator is going to be times by 4. Start with the first cross. We'll go 2x times 5. And remember, you've got to put these in brackets. So it's going to be 5 bracket 2x plus 1. And then we can do the next cross. So that's going to be equal to 4 bracket 4x minus 3. So we've got that there. That looks a little bit like some of the earlier questions we did. We got letters on both sides. You've got an x there and an x there. So what we're going to need to do is we're going to need to expand this out and then repeat over here. So that there is going to become 10x plus 5 when we expand that. And then we've got 16x minus 12 over here. Now focusing on the letters, the smallest of them are the 10x's. So we're going to go minus 10x to both sides. That there's gone. So we've got 5 is equal to, was that 6x minus 12. I can now plus 12 to both sides. So that means, was that 17 is equal to 6x. And then divide by 6 to both sides. Divide by 6 to both sides. X is equal to 17 over 6. You can convert that to a decimal if you want, but I wouldn't stress. I'll just leave it as the improper fraction there. Okay, so we're now onto the excellence question, and we had one fraction over here, two fractions over here. We've now got a triple fraction. So more fractions, harder it's going to get. So that's what makes this an excellence one. So the way I start the questions that have, 3 or more fractions, I look to multiply all of the denominators together. And I'll explain why that's really important. So we've got 5 times 3. Which is 15, and then we're going to times that by 4. That gets us to 60. So what I'm going to do is on the numerator for each of these, I'm going to multiply all of them by 60. And I'm going to put all of them into brackets just to make sure I'm not doing anything silly. So that there, 5h minus 1, that's going to become 60 bracket 5h minus 1. And I'm just noting I haven't cancelled out the 5 anywhere. I've just multiplied the numerator. So I'm going to go over 5, and then I'm going to go minus. Same thing here, so it's going to be 60 bracket 4h over 3, and that will be equal to 60h plus 6 over 4. So I've now got that 60 on the numerator, and noting everything's in brackets, so that just makes my life a bit easier. So this one's a bit weird. I kind of call it the banana method, because if you simplify that bit there, it looks a bit like a banana. So if you go 60 divided by 5, that's going to get you to 12. So that's going to become 12 with my bracket. Same thing over here. We've got 60 divided by 3, which becomes 20. So that's going to become 20 with my bracket unchanged. And same thing over here. 60 divided by 4 is 15. That's going to be 15 with my bracket unchanged. So I've got all of that. Like the last question, when I had all those brackets down there, I just expanded everything and then grouped together the numbers of the letters. That's what I'm doing here too. So that times that is going to be 60h. That times that is minus 12. We've then got negative 20 times that. So that's going to be negative 80h. And that there is going to be equal to 15h times that, which is going to, 15 times 6, 90. So I've now got that. I'm now going to group together these h's on the left-hand side. So that there is going to be negative 12 minus 20h, because I had positive 20 minus 80. And that there will be equal to the right-hand side, 15h plus 90. That's completely unchanged. I'm now focusing on the smallest amount of the letters. And this one's a bit tricky. Most people are going to say 15 is smaller. But remember, that's negative 20. So negative 20 is actually way smaller than 15. So I'm just going to go plus 20. If you did do it the wrong way around, you'll be all sweet. You'll just have a weird extra minus sign somewhere, and you'll just have to be careful with that. So it's going to be negative 12 equals to 35h plus 90. I'm then looking to do minus 90 minus 90. So I've got negative 102 is equal to 35h. And then I'm going to divide both sides by 35 to wrap up my answer. So h is equal to negative 102 over 35. And I initially thought these numbers were really big and there had to be a factor I could simplify. I couldn't figure it out initially, so I put this into my calculator using my fraction button just to check if the calculator spotted a factor I didn't and simplified it, but it turns out it didn't, or the calculator didn't simplify it for me, so that meant that was the simplest answer. Okay, so we're now on to question number 21. Straight away we know it's a wordy question. So we know it's going to be beyond developing in terms of the algebra. So let's get into it. So we've got Brunson is thinking of a number. This number is doubled, so that means it's going to be something like 2x if x is the unknown number. And then this bit's going to be really tricky, and then subtracted from 50. So for example, if I said 6 is subtracted from 10, that there would be 10 minus 6, even though 6 was at the beginning of the sentence. So in this case here, it's actually going to be 50 minus 2x, which is the number doubled. And then he said that's going to get you to a result of 32. And we've been asked to come up with some algebra to determine Brunson's number. I just realized there's a typo there actually. Missed the n. So what we're going to do is we're going to start by doing a minus 50 to both sides. So we're going to have negative 2x is equal to negative 18. You can see a negative sign on both sides. So we can actually just ignore those. So that's going to be 2x equals to 18. And then we're going to go divide by 2, divide by 2. X here is going to be equal to 9. So nice straightforward question in terms of the algebra, but obviously forming that equation was quite challenging, and you need to be confident doing that to get full marks. So we're now into a merit question, and below is the formula for the volume of a sphere. So remember, that's a sphere. If a half sphere has a volume of this, use algebra to determine the radius's area. So what we're going to do is I'm going to start off by doing this. Remember, I've got to times it by half to get a half sphere. So I'm going to have 1/2 times by 4 over 3 pi r cubed. And I know that volume is meant to be equal to 1,250. So 1,250. So my first step here is I'm probably going to look to simplify those fractions there. And remember, we do top times top, which is 4, bottom times bottom, which is 6. And then 4 over 6 would simplify to 3 over 2. So 2 over 3. So that's going to become 2 pi r squared, or r cubed, over 3 is equal to 1,250. So I normally write my fractions like this. That way I can just see it a bit clearer, because I can just now do a times 3 to both sides to get rid of that. Times 3 times 3. So that means 2 pi r cubed is equal to, so that's 3,750. 2 pi is the next problem now. I'm now going to do divide by 2 pi, divide by 2 pi. So that means r cubed is going to be equal to 3,750 divided by 2 pi. And to get rid of that cube, I'm going to cube root both sides. So if I cube root that, the power's gone away. That means I've got to cube root that. So that means r is going to be equal to the cube root of 3,750 divided by 2 pi. And then when I put that into my calculator, I did it earlier, I got 8.46. Don't forget my units are centimeters cubed, so this length here must be centimeters. And I've rounded that to 2 decimal points. So a pretty rough question, probably one of the harder merit questions in here. We're now onto this question here, question 23. This has asked us to rearrange to make x the subject. And when you say, or when you see x as the subject, basically what that means is your final answer needs to be x equals to something else. And in our case here, we can see a C and a B. So that means it needs to be x equals to some kind of math involving B and C. So that's our final end goal, final step for this question. So the same skills apply to your solving. So basically, there's the x by itself, so I need to get rid of this 9 and I need to get rid of this negative b. So I start with a 9 because the negative b is wrapped in that bracket. So we're going to go divide by 9 to remove that times 9. So that means x minus b is going to be equal to 2c over 9. This minus b is going to become plus b. So you're going to have x, also plus b to both sides. So you're going to have x is equal to 2c over 9 plus b. And that matches what we said before, right? We need x equals to something to do with b and c. So we're now on to question number 24. Question 24, you can see it's a fraction. There's a square root in there. It looks challenging, so that makes it a merit question. This is similar to the previous one where we needed to make x the subject. So we needed to do x equals something as our end goal. So let's start by doing that. Noting, it's a bit weird, we've actually got two sets of invisible brackets. We've got an invisible bracket on the numerator, and we've also got invisible brackets inside that square root. So we can't really do anything to do with that square root, or that 3x minus 4, until both the 2a is gone, that breaks down the fraction, and then the square root is gone too. So let's start by doing that. So that's a divide by 2a. So the opposite of divide by 2a is times by. So it's going to be times 2a to both sides. so they cancel. So that means the square root of 3x minus 4 is going to be equal to 2a. The opposite of a square root is a square. So if I square this, that square root's going to cancel. But that means I've got to square this here as well. So that means 3x minus 4 should be equal to, and square root, that's going to be that times that is 4, that times that is a squared. I can now move the 3 and the 4. I've got to do them in the right order though, so that minus 4 needs to go first. That's going to become plus 4 to both sides. So that means 3x will be equal to, what's that, 4a squared plus 4. Then finally that 3 can go, divide by 3 to both sides. That means x is going to be equal to 4a squared plus 4 divided by 3. Now on to question number 25, and this is a nice, fairly basic simultaneous equations question, not too many tricks to it. So basically we're trying to solve for x and y here. So two equations because we're trying to find two variables, x and y. So what I'm going to do is I'm just going to look which variables are easier to deal with. So 3 and 5 are going to be annoying because I'm going to have to times this by 5 to get to 15 and this by 3 to get to 15. That's timesing both of them. I'll prefer to avoid that. The next lot's a lot nicer. If I multiply that by 2, I'm going to get to 4y. Perfect. And that's going to match the 4y here. So my starting point is going to be by multiplying this top equation by 2. So if I do that, that's going to be 10x minus 4y is equal to 38. And my second equation is completely unchanged. So I've got that there unchanged. So I'm now focusing on the y's because they both got the 4 there. So I now need to think, do I have to add or subtract these two equations to solve the answer? So in here, or to eliminate the y's rather. So to eliminate the y's, if we subtracted them, we're going to get to negative 8y. So that doesn't work. So, but negative 4 plus 4 is 0. So I can add them together to get rid of them. So for this line of working here, I need to add together my two functions. So let's add the x's because we've got to add everything. So 10 plus 3 is going to be 13x. As we said, the y's are going to cancel each other out. Perfect. And we've got 38 plus 27. Some messy numbers, so double check on the calculator, but we've got 65. Now, this here, the y's have gone away. We've only got one letter x. We're going to use our normal solving to find that. That's going to be divide by 13, divide by 13. So that means x there is going to be equal to 5. So I've got my first variable, so that's going to be the starting point, but I haven't got the y value yet. So I'm going to pick the easiest looking equation, and I thought this bottom one here looked easy because everything was positive. So we've got 3x plus 4y equals to 27. I now know x, so 3x, 3 times x is going to be 3 times 5. That's 15. So I'm going to put that in its place. So 15 plus 4y is equal to 27. I'm now going to go minus 15 to both sides. So 4y is equal to 12. I could divide by 3, or divide by 4, definitely not divide by 3. So y is equal to 3. And we've got our second answer. So getting both of those with the right working is going to get you your achieve mark. Nothing complicated there. Like there's no math that was difficult. There's just a few things to string together to get to that answer. Okay, now into question number 26. And this carries on in the simultaneous equation section. So basically we know the strat is to form some equations from this here. Because it's a wordy question, it's bumped up to merit here. Let's get into it. So Bo has set up a bakery that sells 2 types of muffins. He's got blueberry and chocolate. The first order had 3 blueberries and 4 chocolates, which cost $23. So I like the look of that because I'm going to use B for blueberry. So it'll be 3 blueberry plus 4 chocolate, and combined that came to $23. So that's my first equation. The second one, similar vibe. The second order was 10 blueberry plus 7 chocolate, which came to $54.50. So I've got those there. I can now start thinking, or basically the question is try to find the cost of each of the things. So that's what those letters B and C mean. So when we solve B, that'll be the price of a blueberry muffin. When we solve C, that'll be the price of a chocolate muffin. So getting into this, looking at the variables, 3 and 10, I can't multiply one of those easily to get the other, so that won't work. And the same with C, that also won't work. So what I need to do in this time around, for the previous question I only had to multiply 1, now I'm going to have to multiply 2, unfortunately. So I'm going to multiply that top one by 10, and that top one there by 3. The idea of getting the b's lined up both to be 30. So drawing a line through there. So that top equation is going to become 30b plus 40c equals to 230. the next equation is going to become 30b plus 21c. That's going to be equal to 600, nope, what's that, 163.5. So I'll draw an underline there. So I've now got my two equations. I've got the b's lined up, which is nice. They're both 30. So I now need to think, am I adding or subtracting these two equations? So we'll call that equation number 1 and equation number 2. And because they're both positive, we can go 30 minus 30 to get to 0. That will eliminate the b's. So what we're actually going to do in our next line is we're going to subtract the two equations. So 30b minus 30b, as we said, is 0, so we can ignore that. Doing the c's, we've got 40 minus 21. That's going to become 19. And then dealing with the numbers, 230 minus 163.5, that's 66.5. I can now solve for c by dividing both sides by 19. That there got me c was equal to 3.5, which remember, the chocolate muffins then cost $3.50. So I'm just adding in the context instead of leaving it 3.5. I can now repeat the same for the blueberry muffins. So looking at these four here, I can actually pick any of them. I'm just going to pick the easiest looking one, which I think is going to be the top there. And I can substitute in c to find that there. So let's go over here. So we've got 3b plus 4c equals to 23. I can take away the 4c because that's going to be 4 times 3.5, which is going to be 14. So we've got 3b plus 14 is equal to 23. I now can do some minusing of 14 to both sides. 3b equals to 9. Divide by 3, divide by 3. That means b is also equal to 3. And that tells us the blueberry muffins worth $3 each. Okay, so we're now into Algebra 2. This is where the rough algebra kicks in. This is the double brackets, the quadratics, the parabolas, all that sort of stuff. So let's get into question number 1. Developing mark only because it's a year 10 skill, but let's factorize this. So the trick with these, there's no coefficient at the front here, which makes our life a bit easier. So this just becomes a bit of a number game. So what adds to 12 but multiplies to 32? And this one here is not as obvious, not as nice as other ones. So when that happens, you need to write a list of all the things that you can think of that multiply to 32. So the obvious one first is always 1 times 32. Could have been 2 times 16. 3 doesn't work. Could have been 4 times 8. 5 doesn't work, 6 doesn't work, 7 doesn't work. So that's our list of our times tables. Which of them add to 12? And it's going to be that 4 and 8 there. So our brackets are going to be x plus 4 and then x plus 8. So we've got our double brackets there. Amazing. So we're now on to question number 2. This one here is an expand. Again, there's no coefficients. There's no trick to this one here. So it's just a year 10 reminder. So we've got rainbow method, m times m. That's going to be m squared. We've then got m times 5 plus 5m. Negative 7 times, or written x there out of habit. So that there is an m. So then we've got the negative 7m, and then finally the minus 35. And when that gets put together, that's going to be m squared minus 2m minus 35. Don't forget, I've grouped together those middle two to get me to that negative 2m. So we've now got an achieved one here. So this was achieved because the numbers were bigger and there was a negative sign here to make it annoying. So there has to be some kind of annoying one, something annoying about it to boost it up to the level. So remember our number game, we're trying to think, well, what adds to negative 15 multiplies to the positive 54. So I'm thinking the 54 numbers first. So it's going to be 1 times 54. It's going to be 2 times 27. I don't think 3 works. 4 doesn't work. 5 doesn't work. 6 works. 6 times 9. 7 doesn't work. And 8 doesn't work either. So I've got my 3 combinations. And you can see how these bottom ones here, even though it's positive, positive 9, positive 6, they both add to 15. We can make that work by making it negative 6 times negative 9. So that there was the trick from going to positive to negative. We can then put that in a bracket. So it's going to be a minus 6. And then the next bracket will be a minus 9. So on to number 4, we're on expanding. Expanding again by itself needs to have a trick, and this time around it's a perfect square. There's also a coefficient in front of that y of 5. So perfect square means you've got to rewrite it as a double bracket. So 5y minus 2, 5y minus 2. So if you don't do that, what people tend to do is they tend to do 5y squared and 2 squared. And I'll explain why that's an issue, because that would have been 5 times y times 5 times y, and then negative 2 times negative 2. But you've missed that timesing, and you've missed that timesing. So you miss 2 of them by doing that. So write it out as a double bracket. So getting into that, that times that, that's going to be 25y squared. That times that, minus 10y. Around the bottom, another minus 10y, and then plus 4. That there, simplifying the y's in the middle, that becomes minus 20 because we're going minus 10 minus another 10. So we've got 25y squared minus 20y plus 4. We're now hitting merit. The reason it's a merit is you can see that number in front of m squared straight away. That's a coefficient. Factorizing with a coefficient is a lot more annoying to do. So we got to use something called the grouping method. Hopefully your teacher talked to you about it. So that times that, 2 times negative 3 is the first step. That's going to become negative 6. So I now need to think what adds to that negative 5 and multiplies to that negative 6. The numbers are quite small here, so it's pretty manageable. Expect better and harder numbers there. But I'm thinking that's going to be, was that negative 6 and positive 1? So they add to negative 5, multiply to negative 6. So I'm now going to split my negative 5m up. So that's going to become 2m squared minus 6m plus m minus 3. And noting it's minus 6 because it was negative 6, plus m because it was positive 1 there. I can now factorize my groups. So that's my first group there, that's my second group there. And we just single bracket to finish this off. And then we convert the single back to a double. So 2m squared minus 6m, they've both got a 2m in common, leaving me with m minus 6 in brackets. M minus 3 actually have nothing in common. So technically, plus 1, or 1's the only factor, m minus 3 in brackets. So I've got the same bracket twice, m minus 3, m minus 3. So I'm going to put that there, m minus 3 bracket, and then the leftovers, which is 2m plus 1, that forms the second bracket. So I've got the 2 there ready, m plus 1. Got that there. So just to note, that's called the grouping method. If you like that method and maybe a teacher didn't run you through that one, maybe hit me up in the comments and I'll reply with a link that helps you with that. Question 6, this is another merit question. It's a rough looking question because at first glance, 25 and 4 have nothing in common and A and B have nothing in common. So you're like, oh, I can't single bracket factorize here. The trick with this one is to recognize this is a double bracket scenario. So this is the equivalent of x squared minus 9, which becomes x minus 3 and then x plus 3. So kind of the equivalent to those ones here. So to get the x's here and here, you have to square root the x, which means we have to square root the 25a4. So when you do that, that becomes 5a squared. And then to get the 3 here and here, you got to square root the 9 to get 3. So we square root this here. So it's going to come 2b. So that's what are going to be in my brackets. But I'm going to have one with a plus sign, one with a minus sign. So that there would then be 5a squared minus 2b bracket 5a squared plus 2b. But now into question number 7, and we've got a messy fraction with a quadratic on the top and the bottom. We've been asked to simplify it. So when you've got quadratics on the top and the bottom of your fractions, basically the trick is to factorize the top, factorize the bottom, and you should have one of the double brackets on the top and the bottom should match, should have one on the top, one on the bottom. They cancel, leaving you with your remaining brackets. So the first one there, that's a difference between two squares. So that there is going to be x minus 10 and then x plus 10. That's going to be over the second one there. So what adds to negative 5 multiplies to negative 50. I'm thinking that's going to be, what, negative 10 and positive 5? So I think I've got that right. So it's going to be x minus 10, x plus 5. And I'm liking what I see because we can see we've got an x plus 10 on the top and the bottom. So as I said, they will cancel out. That there leaves me with x plus 10 over x plus 5. And that there's actually my simple answer. So unfortunately, what some people do is they think the x's cancel out here to do x over 5 to equal to 2. But just a reminder, that's hugely wrong. You can only cancel things out that are factors where there is multiplication happening and that there's addition on the top and the bottom. So these ones here are both multiplication, but these ones here are both addition, so don't go near those. So we're now up to the solving part, which is fun. So we've got it already factorized. So if it's factorized already, and don't forget it has to be equal to 0, you can just split them both up. So split. So I'm going to go z minus 4 must be equal to 0. I can now solve for z, and this one's really crazy to solve. I'm just going to add 4 to both sides. So z1 is equal to 4. I like to write Z1 to kind of denote that it's the first answer of Z, and my next one will be Z2. So moving this over here, so I've got Z plus 7 equals to 0. We now got minus 7 minus 7. Z is equal to negative 7. So that Z2 is negative 7. Forgive me if you're hearing noise in the background. That's my bunny who's decided to stomp in his hutch right next to me. So we're now moving to number 9. Now into question number 9, and this question looks okay. It's still developing because it's a year 10 mark. It's equal to 0, which is good. That makes our life easier, but it's not factorized. So we need to factorize first. When we do that, we need to think, well, what adds to the negative 2 there, multiplies to the 15, and hopefully you're thinking x minus 5 and then x plus 3. So again, that's equal to 0. Now that it's factorized and equal to 0, we can now do our split method from the previous question. So let's split that off. So that means x minus 5 must be equal to 0, which means my first answer here is going to be positive 5. And then the second one here, x plus 3 must be equal to 0, which means my second answer must be negative 3. So next question, we finally hit the year 11 stuff. So this isn't equal to 0. And whilst it looks factorized, it's not fully factorized because we need everything contained in a double bracket. So this involves a bit of rearranging, a bit of work to do. So let's expand the right-hand side or the left-hand side by doing that. So we're going to have x squared plus x equals to 20. I can move the 20 over to the other side, and that's nice because there'll be nothing left over here, which means it'll be equal to 0. So we're going to have x squared plus x, and that positive 20 becomes minus 20 because I moved it on over. I can now factorize here, so I need to think what adds to 1 multiplies to negative 20, and that's going to be x plus 5, and then x minus 4. That's equal to 0. From there, I can get my answers. I won't do a full split working, but remember that first answer there is going to be negative 5. That second answer there is equal to positive 4. So we're now up to a merit question, and again, just a reminder, year 11 is all about fractions, and we've got a fraction messed around in our quadratic. So we're going to need to take some similar steps to the previous question. We're going to need to simplify, factorize, and then make it equal to 0. So we can simplify by moving the x over first. So that becomes a times x. So that's going to be 7x plus 2. That's equal to 15x squared. I now need to make it equal to 0, so I'm going to move everything on over to the side with the x squared. So 7x becomes negative 7x, 2 becomes negative 2. So that there is going to become 15x squared minus 7x minus 2 is equal to 0. I now look to factorize, and it's merit because there's a coefficient there. So I'm going to do so 15 times negative 2 is negative 30. I now need to figure out, well, what adds to negative 7 multiplies to negative 30. Hopefully you've started thinking about your factors, and my answer there was negative 10 and positive 3. So that means I can split this negative 7x, I can split it into negative 10x and positive 3x, because that's mathematically the same thing. So we've got 15x squared minus 10x plus 3x, that's the split I mentioned, minus 2 equals to 0. We now factorize the first group, then we single bracket the second group. So the first group, they've got a 5x in common, leaving me with 3x minus 2. So 3x minus 2. The next bracket, they've got nothing in common, so that means that 1 is the factor. So go plus 1, 3x minus 2 equals to 0. I'm liking what I see because I got the same bracket twice. That means I haven't stuffed up. So that there is going to be 3x minus 2. And my leftovers, 5x plus 1, that forms the second bracket. So 5x plus 1, that there is equal to 0. So I've done a heap of work. I've rearranged it. I've made it equal to 0. I've now factorized it. So now I can do the split part. So this first bracket here, so we set it to 0. So 3x minus 2 equals to 0. We can now solve for this. So we're going to solve by adding 2 to both sides. So 3x equals to 2. I can now divide both sides by 3. So that means x is equal to 2 over 3. So again, that's my first answer for x. I'll write x1. I can now repeat the same for my second bracket. So that's 5x plus 1 equals to 0. I can do minus 1s. So 5x equals to minus 1. I can now do my divide by 5. So that means x is equal to negative 1 over 5. And I'll just write a little 2 there because that was my second answer of x. Okay, now to question number 12. 13 is happening up there as well, but both of these questions relate to reading the context, forming an equation, and then solving for the unknown. And I suppose just as a bit of a hint, these equations are in the quadratic section, so it probably means we're going to be spitting out a lot of quadratics here. So this first one is a bit of a doozy. The question you've got to be really careful with. So Keyes has noted if he adds a number to its square and then doubles it. So a number is the thing we don't know here. So let's say that number is x. So if we have the number which is x, we add it to its square. So the square of x would be x squared, right? And then he doubles it. So doubles it means we multiply it by 2. So I thought that was really tricky to break down. When I reread that, it's clear, but you slow and steady, you got to do it right. That's going to be the same. So the same as our hint for an equal sign to adding 3 to the square's number. So that means it's going to be x squared, and we're adding 3 to it. So that's my equation there. I now need to go ahead and solve. So I'm going to start by expanding out this bracket here. So that there is going to be 2x squared plus 2x. I've just flipped these around to put the x squared first. And that there is going to be equal to x squared plus 3. I can now go minus x squared minus x squared. At the same time, I'm going to do minus 3 minus 3. And that has the effect of making this side here 0. So that there is going to be x squared plus 2x minus 3 equal to 0. I can now factorize. There's no coefficients. So it's actually quite a nice question. That's going to be x plus 3 and then x minus 1. That's equal to 0, which means my first answer for x is negative 3 and my second answer for x is positive 1. So Keyes could have been thinking all of those or any of those two numbers, and that would have made his scenario work. Okay, so we've now got the next question. This is a bit of a doozy. So it's an excellence question to start off with, and the crux of the question is down here. So he's noticed that a perfect square that has one bracket with a difference between two squares, and their difference is always even. So basically what it's asking you to do a perfect square minus a difference between two squares. So we're going to have something squared here, and we're subtracting a difference between two squares. And the question there says these two things have one common bracket. So whatever this is, that has to be one of these here. So let's start by doing that. So because we've been asked to do this, always, that means we can't just shove numbers in here. We've got to shove algebra in here. So let's say that first one there is going to be x plus a squared. We don't know what a is, because if we just put a random number in there, we're going to calculate the number once, but that might mean that's a coincidence. But if we do it algebraically, then it means it'll always be true. So we're then going to subtract the difference between two squares, and remember, this bracket here has to be one of these brackets here. So let's just make that a look a bit nicer. And because it's a difference between two squares, the second bracket has to be minus a instead of the plus a. So I've now got that there. I'm now going to rewrite my perfect square as a double bracket, just to make sure I'm not doing any math errors. I've got x minus a, or x plus a, and then x plus a again, and I'm taking away x plus a, and then I'm taking away, or times by x minus a. So I'm now going to expand both bits. So we're going to have that times that, and then that times that. So that's going to become x squared. So that times that, x squared, that times that. So we've got plus ax plus another ax plus a squared. And we're going to minus, and remember, because we're minusing it with a bracket, you've got to minus the entire expansion. So we're going to go that times that, which is x squared. And because it's a difference between squares, I know that negative a and that plus a will cancel. So we then got minus a squared there. So I've got a few things to do just to clean up. I'm going to simplify these ax's, and then I'm going to do this negative nonsense over here. So we've got, so it's going to become a squared plus 2ax plus a squared. And I'm going to take away x squared because it's take away x, and then it's taking away negative a. So that's going to become plus a squared. So I've now got that. I can now simplify that. My x squareds are cancelling each other out, and these a squareds can be grouped together. So I've now got 2ax plus 2a squared, and I'm really liking what I'm seeing, because remember the end goal, the question said the answer will always be even regardless, and I'm really liking here, because if I factorize out a 2, so let's go 2 bracket a plus x plus 2, or plus a squared, and if we break this number down in a bit more here, so 2 times a number can happen. So that 2 is going to be even, right? So even times odd, which could be the bracket, is even. And if the bracket ends up being even, it's even times even, which is also even. So either way, so it doesn't actually matter what that bracket is. If the bracket is even or odd, because we're multiplying it by 2, we're going to always get that even number. So that's what we're going to need to communicate here. Okay, so as our expression has a common factor of 2, our expression will always be positive. Oh, sorry, always be negative. Oh, sorry, always be even is what we're aiming for here, isn't it? Always be even. I won't actually go into details too much more. I think that's sufficient. Like, we don't really need to explain how the 2 times tables work, and that should be all sweet. Okay, now into question number 14, we've got a pattern here, and we've been asked to find the 6th and 7th numbers in the pattern. So that's basically, we need to find out the next 2 numbers, because we already had the first 5. So the way we need to do this is we need to explore the first and second differences, and to go from here to here, oh geez, we're going to run out of room actually. Let's try to make that smaller. So it's going to be negative 20 to get from there to there, and then it's going to be negative 16, then it's negative 12, and then finally it's negative 8. So those are all the differences there. The difference of the differences kind of in between the 16 and that's got a difference of 4, that's got a difference of 4, and that's got a difference of 4. So we can kind of see that pattern. So the next difference I'm expecting here is to be negative 4. So that means this number coming up here is going to be, so the 6th number is going to be negative 3, which it's currently, and it's going to go minus 4 to get to negative 7. The next difference I'm expecting is 0 actually. So that means the 7th term is also going to be negative 7, because I'm not expecting it to change again. So that must mean the vertex kind of sits in between those 2 points, as a side note. So if you get the first bit there, that's your developing mark, because it's pretty cruisy. You can kind of lock that in, upgrade it to an achieve mark by getting B right. And the question has really simply asked us, is it an exponential or quadratic pattern? Justify your answer. The same first difference tells us it's not linear, but the same second difference tells us it's a quadratic. If we had an exponential graph, we would have had different second differences. So our pattern, let's talk about our pattern. So our pattern has the same second difference of plus 4, the same second difference of 4. This tells us it is a quadratic. Okay, so we're now on to the last run of questions. And then just a reminder, this exam is a bit longer than the real one, so you won't be as pumped for time as you are for this practice one. So basically, we've got 3 graphs. We've got 2 parabolas. You can see this green one, it's a solid parabola. The dotted line is the dotted parabola, and then obviously we've got the straight line kind of kicking through there. And for achieved, we've got a straight line question. Find the equation of that straight line. So remember, the equation of a straight line comes from the equation y equals mx plus c, your gradient and your y-intercept. So y-intercept is the c value. That's the easiest to find, and that's the 8 that's sitting up the top there, right? So that's c equals to 8. My gradient is a rise over run calculation. So if we have a look there, we can see it drops 2, so that's minus 2 as it runs 1. So your rise over run here would be negative 2. So that means my equation here, y is equal to negative 2x plus 8. So it starts at 8, goes down 2 every time. So we're now on to question number 16. This relates to the parabolas. So we've been asked to determine the equation of the dotted parabola, and we've been told a is equal to minus 1. So our normal equation for the parabola depends on the type or the information that we can see. So we're looking at this blue dotted line. So this vertex here, I'm not super sure exactly where that vertex is, so I could use it if I wanted to, but I am actually really sure about my x and y intercepts. So I'm going to use my x-intercept form here. And writing that down, that's y is equal to a x plus b x plus c. Remember, they've already told us what a is equal to, so that's just going to be a minus sign. So let's change that out now. So y is going to be equal to negative x plus b and then x plus c. The b and c values come from the x-intercepts. That's why it's the x-intercept method. So we can see our intercepts here at 3. We can also see it here at 5. And I want to note, because these two numbers are going inside a bracket, inside the bracket there for c, you've got to do your opposites. So our b value is actually going to be negative 3, and that represents the opposite of positive 3. And our c value is going to be negative 5, and again, that represents the opposite of the positive 5. So now that I've got that sorted, I can state the full equation. It's going to be negative x minus 3, that's my first bracket, and then x minus 5. Now onto question number 7. We've been asked to find the equation of the solid parabola, and because it's a merit question, straight away we know that a is going to be annoying to figure out. So the first step, like the previous question, we want to figure out what method do I want to use, x-intercept or vertex method. And looking at the x-intercepts there, we can see it's randomly between 1 and 2, randomly between 4 and 5 there. I don't know what those numbers are, so the x-intercept method's not going to work. Checking the vertex, I can clearly see that vertex, can't I? So that vertex there is at 3, negative 6. And that's really good information. That tells me I need to use the vertex method. And that's in your formula sheet as well, if you remember. So we've got y is equal to a bracket x plus b squared plus c. So I've got that there. I now need to figure out all my values. So just a reminder, a means you've got to use for algebra. So I remember a for algebra. So I can't do a yet, but we can do b and c. B relates to your left and right movements. So my parabola should have been over here at the origin, and it's been moved across here to positive 3. And again, that number's going inside the bracket, so it's going to be the opposite of that. So my b value is negative 3. The c value here, that relates to my up and down movement. It's then been moved down 6. The c is not in a bracket, so that means the regular answer, negative 6, just stays as it is. So I can put that together. So y is equal to a, which I need to do later, x minus 3 squared minus 6. Okay, so I've got a. So the easiest way to find out a is if you go across 1, up 1 on your graph. So go across 1, up 1. If it intersects that point there, we know a is equal to 1. But it doesn't here, which means it's going to be really annoying. So what we need to do is we need to find another coordinate on our graph to then figure out what a is going to be. So I can see this point here, actually. I saw this one here that looked really nice. Just over there. And that coordinate there is 2, negative 4. So what that tells us is that tells us an x value. It also tells us a y value. So I'm going to substitute that in for y, and I'm going to substitute that in for x. And when I do that, I'm left with one letter, just a. I can use algebra to solve that. So as I said, y was going to be negative 4, wasn't it? So negative 4 is going to be equal to a bracket, x needs to go away, that becomes 2, so it's going to be 2 minus 3 squared minus 6. Do your BEDMAS to simplify this first. So 2 minus 3 is negative 1, negative 1 squared is positive 1. So that means negative 4 is going to be equal to a minus 6. I'm going to add 6 to both sides. 2 is equal to a. So that means our a value is 2. So this line of working here is now what I'm going to move from. I'm going to rewrite it there, but I'm just going to get rid of the a and put in the 2 that I know it to be. So that means y is going to be equal to 2 bracket x minus 3 squared minus 6. So we're now on to question number 18. Question number 18 is the last question in this exam, and it's a doozy. It's the big parabola excellence question. So we've got, if the solid parabola, remember that's the green parabola from question 17, if that's translated down to left 1, where would the translated parabola intersect the straight line? So basically what's going to happen is this green one, we're going to kind of redraw it moved, and then we need to figure out where that parabola is going to touch that straight line. So the first thing to note, the straight line is easy to do. So the straight line equation, we did that in the developing question before, and if you didn't do that question, you would have had to do it here anyway. So you got y is equal to negative 2x plus 8. So that was from our previous question done here in 15. The translated parabola is the next part. So translated parabola. And while it's annoying to come up with the equation of parabolas because of that a value, the a value is going to stay the same. It's only been moved up and down, left and right. So that just means it's going to be the negative 3 and the negative 6. That's going to be the only things changing. So let's try to imagine. So our current vertex is down here. So we know it's going to move down 2. So it's going to come off the grid here. So we're going to have to imagine it a bit better. And then it's been moved left 1. So that's going to be down there at negative 8, isn't it? So that means our parabola will have a vertex there, and it will look a little bit like that. So that means our horizontal movement is now to 2. So that means that 3 there is going to have to be negative 2 instead. So that there is going to be negative 2. Negative 2. And then the up and down movements change a little bit. It's now moved down to 8. So that means that negative 6 has also changed. That's going to be positive, also negative 8 now. So we can update the negative 3, update the negative 6 to get the new one there. So we've got y is equal to 2 bracket x minus 2 squared minus 8. Okay, so the next part of the question, and this one's going to be the tricky part, is we now need to find out the coordinates when this new parabola intersects this new straight line. And what we know from the question is at those points of intersection, you're going to have the same y value for both of them. So that means y is equal to y, which means this straight line, when's it going to be equal to this parabola? So when is 2x plus 8, when is that equal to 2 bracket x minus 2 squared minus 8? So we need to set them together and then we solve. This is only going to give us the x value. Remember, we've been asked to find the coordinates. So we're then going to have to figure out the y's after that. So we'll do with that soon. And the first thing I've noticed, and this might make my life easier, do you know everything here is a factor of 2? So we've got 2 here, 2 here, 2 here, 2 here. We can divide everything by 2 just to take out that common factor. So let's go divide by 2 to each of our parts. So negative 2x divided by 2 is going to be negative x, and then it's going to become plus 4. Those 2's will just cancel, so that will be x minus 2 squared, and then we've got minus 4. I can now look to expand this perfect square. So we're going to have negative x plus 4. That's going to be equal to x squared minus 4x plus 4 minus 4. Those there cancel each other out. So we're going to have negative x plus 4 equals to x squared minus 4x. So it's going to be a quadratic. So my main priority now is setting everything to 0. So let's make all of these things go over here by doing their opposites. So that negative x will become plus x. So I'll put a plus x over here. And that that positive 4 becomes a minus 4. So minus 4, minus 4. So all of that cancels out, which is what we want, 0. So 0 is going to be equal to x squared minus 3x minus 4. And from here, this is a nice quadratic. There's no coefficient here. There's no coefficient. As in the algebra is slightly easier than it normally would be for an excellence question because you had that trick with the parabola translation, so that made the question harder, so we made the algebra a bit easier. So that means 0 will be equal to x minus 4, x plus 1. From that, we can solve x1 is equal to 4, and then x2 is equal to negative 1. So I've got my two x values, but I don't have those coordinates. Remember, the questions asked us for coordinates. So my straight line formula will tell me what y is. So y will always be equal to negative 2x plus 8. So I need to figure that out. So we're going to have y1 over here. That will be equal to negative 2 times x, which is 4 in this case. And then we've got plus 8. So that there is actually going to be 0, right? They're going to cancel each other out. Y2 is the next bit. It's going to be negative 2 times negative 1 plus 8. That there comes to, well, so negative 1 times negative 2 is positive 2 plus 8 is 10. So from that, I've now got my sets of coordinates, right? So the first one there is going to be 4, 0, and my second set there will be -1, 10. So that wraps up all of the questions. So this video was a bit of a marathon, over 2 hours, but I just want to remind you, this exam, I put more in there just to give you more rigorous practice. And the final thing to note is I'm not going to be going over any of the optional section. That's going to be a complete surprise to everybody. I haven't even showed most of the maths teachers. So best of luck if you're aiming to gun those and really excel through some of those extension topics we looked at through the year.